Hey friends, how we doing? Welcome, welcome. Plug my Twitter here. Hope everyone's having a good day so far. We'll get started in just a few minutes here. Hey, early birds, welcome, welcome. We'll be started here very shortly. Hello, hello. Did everybody have a good day today? I don't know about you, but it was hot, hot where I live. We bumped up to about 95 degrees Fahrenheit here where I live. I don't know about you guys. After it had been like, 50 degrees Fahrenheit for the last week. Yeah, same here. Yeah, it's wild stuff. Hopefully things settle down a little bit. Hey, hey Lilo, Emleg, Bail Bob, yeah. And I'm in the upper Midwest, so that was very interesting. I had to go straight from sweatshirts to shorts. Got the AC going, all that good stuff. Actually, I think I may have to turn the AC down a little bit. It's a little starting to get a little too cool in here for my shorts. So I'm going to go on mute for a second and turn the AC down. Hey, welcome, Intelligence. How are ya? I don't know about you, but I'm looking forward to today's topic. We're going to talk about promises and asynchronous tasks, and yeah, it's going to be good. There's I don't have a big project tonight. We're just gonna kind of meander through the javascript.info and kind of just talk through it together. It's gonna be good. Read the homework just in time. Nice. Yeah, I will say I haven't watched the YouTube video yet, the YouTube assignment. So if there was anything particularly illuminating in there, I haven't seen it yet, but I definitely will be watching it. Happy Wednesday, Nebula. Yeah, Rascal. I mean, I can definitely see how promises and async await are very powerful base Legos. Um, and, I can see a lot of potential really valuable use cases for them. Read Ev, it's 90 here. Oh, Silent, welcome back. Hi, Silent. How are you doing? Good to have you back. It's 90 here. Yeah. Okay, let's get it going. Good to see you all. Um, Hello, hello. Sorry, the lighting is kind of weird. It's just very sunny right now. uh, welcome, welcome. So, yeah, today we are going to. Oh, Daddy's home. Hi, welcome. Glad you're able to join the stream live. It's awesome. um, yeah, so today we're going to be kind of talking through the javascript.info chapter that we were assigned. And, we'll be doing the tasks too. But there's not a ton of tasks. So I thought, it might be fun to just kind of go through the text. I'm not going to read the text to you. I don't I don't do that, but we're going to kind of go through and sort of just talk about the concepts. And I have no idea how long it'll take, but it'll be fun. Oh, got to turn on my closed captions. One moment. And look, we kind of like Legos, let's step on them. Oh my goodness. Yeah. My dad encountered that several times when I was younger and would leave my Legos out coming through the living room. Get one of those little round pieces, like the ones that you use for like coins or whatever. Get one of those right in the bottom of your heel. Oh, fun stuff. He was not happy. Okay, let me turn on my captions real quick. 2 seconds. Oh, come on. It's going to make me log in again. What? All right. Starting captions now. Okay. Captions should be on for you if you need them. Feel the pain. Pain is good. Oh, yeah. Yeah. I'm glad you're hyped about tonight's topic. Like I say, so, we're going to kind of take it slow and go through it just because I don't fully understand, all of this yet. I know it's very powerful, which is why I wanted to cover it tonight, early in the week, so that we can kind of just slam into it face first for now and talk about it, talk through it, do the tasks, and then we have it in our heads and we can think about how to apply it for things coming up. And I'm sure Leon's going to talk about it again. Um, I don't know when he's going to talk about it again, because I think this Thursday is going to be another one of another very valuable class on how to get an interview and get a job. So I think it's important to kind of touch on these things, think about them, get them in your head, maybe think about how to apply them to some of the stuff that you're doing. Like I know that I've used promises. I used promises on the Jeopardy game that we built a few weeks ago, because for that game, I had to make multiple calls to the API over and over again to get my list of categories. Um, so that I had to make like I forget how many categories. It's like five API calls at the same time to hit slightly different URLs for different categories, and then just basically had to use a promise. Had to wrap all of those in a promise all, and I probably should have used a promise any, but I had to wrap all of those in a promise all, and then return the results once all of those calls to the API were resolved, and basically drop all the results into an array. And so I thought that was really cool how I was able to I used it without knowing anything about it. But now we're going to kind of cover it again and talk about like promise all, promise any, that kind of thing. Talk about those things a little bit more. So this might be a little bit different than some of my other streams where I hit the task hard, hit them fast. We just slam through it. This is going to be more of like, let's talk about what's in each section. So hey Dakota, I hope you're having a good day as well. Yeah, and Sunday is a super review day as well. As far as when my stream will be on Sunday, I don't know. It I actually have some family coming this weekend, so it may be that there is no stream on Sunday. It just depends on how it goes. As always, follow me on Twitter. I'm gonna um, put my Twitter here in the chat, and I will announce whether or not we're even having a stream on Sunday. Um, it may be that I just go live as soon as Leon's done, whenever that is. We'll just see how it goes. We'll play it by ear. It's all good. Yeah, the super review Sunday. Yeah, that's what I mean as far as like potentially, you know, having the Sunday stream be up in limbo a little bit, but that's okay. It's all good. We can be flexible. Hey, Akechi, welcome. All right, so let's go ahead and get into it. So the first section is on callbacks, and we're not going to linger too long on this section. just because it's more of just like understanding what a callback is and less about like knowing everything about callbacks, because they're kind of not what we're going to be focused on. We're going to focus more on promises and async await, because those are more flexible and can do more things. Well, can are easier to read and write, I would say. um sure, Schrodinger's streams, yeah. It's, yeah, can't tell if it's happening or not until it does. Yep, exactly. So let's go ahead and get into callbacks. Can you guys see this okay? Is it big enough? I made the text a little bigger, so hopefully you can see it all right. Okay, so we're not, like I say, I'm not going to read this to you, but I do want to touch on, okay, so what is a callback? So essentially, good. Okay, awesome. So so um, a callback essentially allows us to, I'm gonna go down here. Yeah. So a callback essentially allows us to wait to execute something until we're done with something else. So in this case, what this particular function is doing is it's saying, um, we're passing in a source, and then we're passing in a callback um, as two. Down here, we're passing in a source and a callback as two arguments to this function. And what it does then is it sets the script as creating an element in the document, um, and it sets the source of that script as a source. And then it says, all right, once the script is finished loading, then do you go ahead and call back and actually create the element and then append it. So basically it's saying, all right, wait, hold off, don't do anything else. And then only once the callback is executed, then do the next thing. And so it's basically, it's not allowing, because um, how the browser likes to run is it likes to try to compile as much as it can synchronously, so at the same time, right? And sometimes we want to force things to be asynchronous so that they happen in sequence. So one thing two, thing three, thing four, because sometimes something isn't going to execute properly until the prerequisite task is finished, right? So sometimes, like, we want to, like when we're doing a fetch, right, when we're hitting an API, we can't start doing stuff with the data that we get back until we get that data, right? So sometimes we have to force things to run in a particular order. Um, and so essentially, callbacks are a way to do that. But problems can arise when you want to have many items in sequence. And so they actually have a name for that, and it's called the pyramid of doom. So for example, it says, at first glance, it looks like a viable approach to asynchronous coding. So if I want to force things to run in sequence, I can just do a series of callbacks, right? I can do thing one, then call back to do thing two, then call back to do thing three and thing four, right? And force them to run in order. But you can start to get kind of a rat's nest of callbacks, all trying to get them arranged in the right order, and it can become very hard to read. And so it says, at first glance, it looks like a viable approach to asynchronous coding, and indeed it is. For one or maybe two nested calls, it looks fine. But for multiple asynchronous actions that follow one after another, we'll have code like this. And you can see that we're getting quite a lot of nesting happening here. And so when we start to get this deep, when we start to get this deep into indentation, you got to think there's got to be a better way to do this. And it says, in this code here, we load 1.js, and if there's no error, we load 2, and if there's no error, we load 3, and if there's no error, keep going, right? And this is sometimes called callback hell or the pyramid of doom, which I really love. That's awesome. Love me a good doom pyramid, and then this graphic is amazing with the little devil head there. So yeah, that's not good. So I mean, they do say that you can alleviate the problem a little bit by making every action its own function. So um, in this case, what it's doing is it's calling the first iteration of the function, um, and then it's creating individual step functions to call further iterations of the function. Pyramid of doom, yeah. Yep. And so, that's one way to do it, but we have, far better ways that we can, kind of chain, that we can create a sequence of steps that are far more easier to read. Temple of Doom, yeah. Yeah. So really, this first section, I don't want to linger too long here because I don't want to get things confused, right? We're going to focus on what we need to focus on, which is mostly promises and async await. But callback. It's important to know what a callback is trying to do. It's basically just saying, all right, we can use a callback to basically hold an additional step until we're done with something else. Yeah, and callbacks do definitely have their place. We've seen them before, but for the types of things that we're trying to do, I think we're going to focus more on promises. Yeah. Temple of Doom. Yep. All right. So let's learn about promises. So essentially, what a promise is doing is it's essentially you can pass into it something, and it's going to execute that and essentially return a resolve or reject. Um, us baddies being given Egypt a run for its money with our code sometimes. Yeah. And the analogy that the text gives here, however effective you think it may be, is essentially saying that, a promise is kind of like if you're like an author or a singer and your fans know that you're going to be putting out a new piece of work pretty soon. And so essentially, you got fans asking, keep asking, keep asking, keep asking for you to give them something, to give them this piece of work. And you say, all right, I'll send it to you when it's done. Just wait, please. And so they say, all right, I want to give you my email address. Tell me when you're done. Tell me when you're done. And so you say, all right, give me your email addresses, and I will let you know as soon as it's done. And so in that way, you alleviate the pressure, and you know that fans aren't going to go looking for your music or for your work before it's done. They're going to wait. They're going to wait until it's done. Winds of Winter. I gotta say that was in my head. Yeah, yeah. George R. R. Martin has had a promise pending for quite some time now. Yeah. So and there's some terminology we can start to kind of carve out in our heads a little bit here. Um, so in this case, a producing code um, it does something and it takes time. So it could be a fetch, like API fetch or something or um, hitting a URL or loading a script, right? It takes time. Um, oh, enclaved. Suddenly you understand pending promises. That's awesome. Great. A consuming code. So a producing code is the thing that's loading a script or hitting a URL or something like that. The consuming code then desires the result of that. So it's maybe a function that needs the result. Um, and oh, I'm sorry, my old dog has just come out into the room. I need to put him back. Give me just 2 seconds. He can't be wandering around out here. 2 seconds. I gotta go on mute. He's going for the laptop intercepted. uh, yeah, no, he just comes out and wanders around, and he has balance issues, so it's not good for him to be out on the hard floors. Okay, yeah. So let's get back to it. All right. So producing code is the thing that's that does something that produces a result and takes some time to maybe deliver that result. The consuming code then is the thing that needs the result of that producing code. It needs that in order to do its job. And so the promise is the object that links the producing code and the consuming code together. Um, and so the producing code takes all the time it needs, as long as George R. R. Martin takes to write his next book. Um, and then in the promise is kind of like the mediator, and it says, all right, consuming code, just chill for a hot second until the promise is done, and then you can have everything that you want. And it makes so it makes the result of the producing code available to the consumer. It's almost a promise that the dog will be wandering. When it resolves, mine's consuming code goes and puts them away. Yeah, pretty much. Yep. Okay. So here's the basic syntax for a promise. So essentially, we say new promise, and then we have our function and all the stuff that goes inside of that promise. So pretty simple. We've seen this new keyword before, when we're calling a class or constructor or whatever. And the function that we pass in is the executor, which is a great name. So and let's see. And so then the two arguments inside of that executor are basically resolve and reject. And so um, if the job finishes successfully, then we get a resolution and we can pass a value out of the promise. And then if the promise does not resolve successfully, well, if the promise is unsuccessful in getting the result, then we can pass out an error. And the question was, are the parameters two functions? Yeah. Yep. And they can return multiple things. And we'll see the examples of that a little bit later. Okay, so promises have several different states that they can be in. So while it's running, it's pending, and you might see that when if you ever executed a promise in the console, which we will do, we'll run a few things in the console just to see how they behave. You might see pending, and it'll then change to fulfilled when resolve is called, and then rejected when if rejected is called. Yeah. And then the value starts with at undefined and then changes to a value if resolve is called, or an error if an error is called. And what's interesting is that the promise is considered essentially fulfilled no matter what the result may be. So there can be a variety of results that are returned and the promise is still successful. So we'll see that in a little bit as well, I think. Okay. Yeah, so let's run this in the console. So this is a simple promise. And this function that we pass into the promise is automatically executed when the promise is constructed. And so we'll see that when we pass this in. Yeah, so in the time, we are setting a timeout here. So it's going to resolve after 1,000 milliseconds, which I think is 1 second. Ooh, thank you. So I think was that a second? Oh, I guess there's no alert here. Sorry, I thought there was an alert here that was going to alert after a second. I was like, why is nothing happening? Yeah. And so it is going to go ahead and fulfill the promise with a resolve after 1 second. Okay. All right. And so then we can also reject the promise if you don't use set timeout, is there a default? If you don't use set timeout, is there a default timeout period? I don't believe so. No, because I've seen promises when there's an error. If it essentially just stays unfulfilled until you reload the page, and we'll get into that a little bit with unhandled exceptions. If it can't um, fulfill and it passes an unhandled exception, I mean, Rassel, you can correct me if I'm wrong, but I believe it just crashes out until you reload. Okay, so we can reject, we can resolve, but essentially the executor, so the code that we pass into the promise, should perform a job, something that takes time, and then call resolve or reject to change the state of the corresponding object. Hey, thank you, Isachulo. Welcome. Glad you're able to join us. And as far as the result of the promise, and so yeah, this is kind of what I was saying earlier. A promise is a promise that is either resolved or rejected. So either we get an error or a value. Either a promise that is either resolved or rejected is called settled. So it's done. It is, the promise is completed. Even if you didn't like the result, the promise is completed. Um, and and also there's only going to be, a promise is only going to have one result. Any state change, so any state change for the promise is final. So any further call, so if you call resolve and then you try to do something else inside of the promise, it's already been resolved. It's done. The promise is fulfilled. Promise is like, I'm bounce, I'm out. And Rascal says the exception could be handled, but depending on the environment, it throws, but doesn't always prevent code around it from running. Just code directly depending on the value of the promise. Yeah. So if a promise hits an exception that it can't get around, that definitely doesn't prevent code around the promise from running, but the promise itself is going to be stuck until you reload. Yep, and piece of shoot. Yeah, 404. So 404, which is, that's what a page returns when, page not found, right? I'm sure you've seen that when you hit a website with a broken link. 404, page not found. If you hit, like, say, an API that returns back that error code, then I mean, you got something back. You got the result, and so that promise was successful. It hit, yeah, sure, 404. That's a result. Cool. Bye. And then the promise is over. So you can do additional. You have to do additional handling for that kind of thing, because the promise still thinks, "Yep, I got a result. I'm good." Okay, so but we can only get a single result, whether that's an error or a value. And it just says, in case something goes wrong, the executor should call reject, and we should throw errors when we get something wrong. Yeah, and only actual network errors are considered errors according to the fetch specification, but it's not the same for everything. Yeah, I'm sure there's differences depending on the library you're using. Okay. So along with promises, we can start to add additional functionality that occurs after that promise is completed. And we've seen this before. So we can talk about consumers. So remember, we have producers, we have consumers, and the promises are the mediator between the producer and the consumer. Yeah, yep, Isachula. We're going to get into that in just a little bit. We're going to get into fetch and we're going to get into fetch and then and catch and all that. Yeah, absolutely. Yep. So essentially, the promise is the mediator between the producer and the consumer. And so now we're going to talk about consumers a little bit. So we can talk about consumers that we may have already seen. So what is then and what is catch? So a promise object, remember, serves as a link between the executor, which is the producing code that we put into our promise, and the consuming functions. And consuming functions can be registered using then, catch, and finally. So the most important one, obviously, is then. And so what then does is the function that resolves, sorry, the function that runs only when the promise is done. So so the something you wrap in a then can only execute once the promise is resolved. And the second argument of then is a function that should run when the promise is rejected. Um, so here's a function, here's a reaction to a successfully resolved promise. So let's run it. So well, let's look at what it's doing first. So we're creating a new promise. So we got a function resolve reject. We set a timeout, and we immediately say, okay, we're going to resolve this promise. We're gonna manually call resolve and say, yep, it's good. The promise is fulfilled. And so then we can basically say, all right, after the promise is fulfilled, then if the result was successful, we pass the result into an alert. And if it was unsuccessful, we want to pass the error into an alert. So let's see if we can run this. Yeah. So look, we got an alert up there. It's probably kind of hard to see, but we got an alert that says done, which is exactly what we passed through in our resolve. uh, yep. So with node express in MongoDB, we are essentially using promises within fetching. Yep. What did Jim say? Called out Rascal 2 on Discord. Look back over at a stream and they just posted here. Yeah. Yeah. Rascal's everywhere. I always see that. I see them everywhere. They're helping out. They're omnipresent devs. That's exactly right. So now let's see what happens if a reject is used here. So the result of the promise is reject, and so we pass that after the promise is completed. Remember, it's settled. It doesn't mean it was successful. After it's settled, no matter what the result may be, in this case, we're going to get an error. Whoops. Yep. So that's the error, is whoops. I don't know about you, but like I'm from the Midwest, and so we don't usually say um, like oops or whoops. We tend to say like whoop. I don't know if anybody else says that. But we're like whoop, whoop. Let me just squeeze past you there. Oh, yep, yeah. It's interesting. Some folks like more up in Canada and Michigan, I think, say like oop, oop, but I say oop. There's a slight pronunciation difference, and it's really interesting. That sort of regional the regional enunciation. Yeah, whoop doo doo. But I think the let me just squeeze past you there is a very Midwestern phrase. That's all we say in Michigan. All right. Yeah, exactly. I'm pretty close there. I'm from Indiana, so it's a slight variation, but still quite the same. Yeah. uh, I love little linguistic quirks. Okay, so we got an error, sure. Um, but there may be times when in a promise we're only really interested in success. We don't think we're ever going to get, we don't think maybe we're ever going to get a failure or an error, and so we don't have to pass in we don't have to pass in one argument to then, in which case we just alert the result. So we know, for example, we know that this promise is always going to resolve successfully after a second, and so we can just say, all right, pass this result, which is always going to be successful, pass that in to the then and alert it. So we can test this out. So look, all we passed into our then was just alert. We didn't pass in anything to the alert itself, but it's still going to work. Yep, still going to work. So I thought that was kind of neat, is that you don't have to pass in, pass in anything into the alert statement. You're just saying by default it's going to alert what we pass into it, which I thought was kind of neat. Okay, so the next thing to talk about is catch. So we have then, which will do a thing after a promise is completed. But what catch does is it kind of serves as like a repository for all of our problems. If we're chaining, for example, if we're chaining multiple thens together, which we may have seen when we do like API calls and stuff like that, we can kind of use, like, I kind of think of like a catch as like the bucket that you put at like the bottom of a gutter, so you know that all the junk coming out of the gutter is just gonna fall right into the bucket. and it's gonna catch all the stuff that doesn't that doesn't cut it. Yeah, and it's safe for code that can't throw errors. Yep, that's kind of what I was saying here. Is that this particular promise cannot throw an error. It's always going to resolve successfully. So we don't need any error handling. Um, it's we can just say we know for a fact it's always going to be successful. So we just alert the success. Yeah, good question though. All right, so catch is our wonderful bucket, and we're essentially I'm not gonna like spend too much time on it now because we're gonna have better applications of it later. But yeah, catch is like our error bucket where we can send all of our errors and spit them out. Catch is the error parachute. Yeah, kind of. Yep. And so finally, we'll talk about finally. And finally was one I hadn't seen before. And Rassel, you have more experience with this than I do. How often do you see finally, or anybody else that has extensive experience with promises? How often do you see finally? Drop. Yeah, unfortunately I don't have the drop game on my stream. I'm not that fancy. Juicebox Hero is way more fancy than I am. Senior K. Okay, thank you for sharing that. Yeah, so I hadn't seen finally before. But I mean, we're still going to talk about it, but I don't know how often you're actually going to see it. Yeah. Oh. Okay. Um so finally is a good handler for performing cleanup. So essentially what it does is it essentially it does the thing no matter what the outcome is. That's um so there's no arguments. We don't pass anything into it. We don't know whether the promise was successful or not. It doesn't matter. We just want to do the thing. So just close it out, do the thing. Doesn't matter if the promise was successful or not. Um, and it can also serve so we can use it to so in this case what they're using it to is to stop a loading indicator. So it doesn't matter whether or not the load was successful. We just want to stop the indicator and then pass the result of the load into some additional handling. So, I mean, like I say, I don't know how useful this is, but it's just important to kind of know what it can do. So if you ever see it in production code or something, you can know what it's doing. Know that since it doesn't care about the result of the promise, nothing is passed in. So it just does the thing once the promise is done, just does it. It can pass through, so it doesn't do anything with the result, but it can pass it to like an additional then or a catch. um, so in this case, here's an example. So we have a promise here and with a timeout, and once that promise is completed, we don't know what the result is. It might have been unsuccessful, but we still want to, no matter what the result of the promise is, we want to alert promise ready. And then after that, we actually alert the result of the promise. Yeah, I mean, the promises can. I've been kind of messing with promises for a while without really knowing anything about them. I like to just throw stuff at the wall, right? We're bad. We're baddies writing bad code. We throw stuff at the wall and see what sticks. And so I've been using promises for a while. And yeah, if you don't understand what they're trying to do, yeah, you can kind of get yourself in a bit of a hole as far as okay, how do I make this work? So yeah, it can have a few gotchas here and there. But if we start talking about it now, then we'll start understanding it more as we go, as we repeat it more. We get more of that repetition in, right? Oh, rascal. Turns out I'd used finally recently to close an open process no matter if the code worked or broke, and elsewhere to console log and write the state to a file no matter if it worked or not. Yeah, I think that's a great application of finally, right? Because whether or not it worked, sometimes you just want to end a process. And then you also want to console log the result of that process, of that promise, to somewhere so that maybe you can debug or troubleshoot. So yeah, that's actually really cool. I like that. I like that use case. Okay. Yeah, and so here's another um, little tidbit, I guess, about how promises work. So um, if a promise is pending, then catch or finally or whatever, these handlers will wait for it to finish and then they'll run. But if a promise is already done and you append a then to it or a catch or whatever, it'll just immediately execute because it says, all right, the promise is done, I can run. So basically, whether, it just waits until the promise is done. And if the promise is already done, it immediately executes. So if the result is present, as soon as the result is present, it'll run. Okay. So here we're writing a callback script using promises. Let's go ahead and let's go ahead and do a quick review and then we'll do the tasks, okay? So promises allow us to do things in the natural order. So we want to run our script first, and then we want to write the result to something. So, it makes sense to us, like if you think about it logically, but the way the code runs, if we don't force that particular execution order, the code might try to run synchronously at the same time and try to execute itself before it has all the information it needs. And so, by using promises, we can force things into a particular order in order for it to make sense logically for us. Um, so that's the advantage of promises versus with callbacks. Like we talked about callbacks before, which do something very similar, right? But in order for callbacks to work, we have to essentially pass in the callback function when we call at the same time we call the first function. So we must know what to do with the result of our first function. Sorry, we must know what to know. We must know what to do with the result of our first function before we call it. So promises make more sense in a logical order of things. And we can essentially call then. So we can chain. We'll get into this a little bit later, but you can chain multiple thens one after another after another after another. Versus with callbacks, you saw what happened earlier. We got the pyramid of doom, where you end up with a horrendously like a rat's nest of functions, right? Trying to force those callbacks to call each other. But with then, you can just say promise, then do something, then do something else, then do something else, then do something else, then catch all the errors. And don't be making promises you can't catch. Okay, so let's put this into practice a little bit. Let's think about this a little bit. So, um, re-resolve a promise. What is the output of the code below? So we have a promise. We declare a new promise, right? And we have a resolve here, which resolves to 1. And then after that, we have a set timeout, which then what it's trying to do is then resolve to, like wait 1 second and then resolve to 2. So resolve to 1 first, wait 1 second and resolve to 2. And then after that promise is finished, then alert. Will this work? Will it do it? Will it resolve 1 first and then 2? Feel free to guess if you don't know. You guys know. So you think it'll just resolve to 1? Yeah, Tony Stark. That's a great name. Yeah, there we go. Coming in, Prophecy 111 coming in hot with the first time chat. Welcome, welcome. Got a 50-50 chance, right? It's all good. Okay, so got a lot of folks saying 1, and yeah, you're actually right. So, and Tony Stark kind of hit it on the head there. Yeah, so a promise can only resolve or reject once and not twice. And so let's test it. Let's see if we can. Let's reload this and run it. Yeah. So you see, it resolved to one, and the promise is completed. So after this resolve statement here, after we said it's resolved and we passed one out of the promise, then the promise is like, all right, I'm done, I'm out, I'm done, bye. Even though there was more to do here, but that resolve was like, all right, my promise is fulfilled, I'm out. It reminds me of, you know, that scene in the Lord of the Rings, where Aragorn, so like Aragorn gets those that green ghost army, because they had an oath, right? They had an oath and they were trapped as ghosts until they fulfilled that oath. And he brings them to fight, um, like all the orcs and stuff, and the big final battle, and they come off the ships. And at the end of it, he's like, your oath is fulfilled, and the ghost guy just like poofs into green mist and flies away. Like, I mean, there's more he could have done, right? Aragorn could have kept him around, but you basically said, all right, you're resolved, you're done, and the ghost just went poof and disappeared. Yeah. The way is shut. The dead keep it. The way is shut. Yes, absolutely. I really like the Lord of the Rings. I've actually okay, you're gonna hate me for this, but I've never read the books. I've only ever seen the movies, but they're fantastic. So yeah, and that's a good point, Rascal. So the set timeout still runs. It still does run, but the result is ignored, and the first result is what's passed into the alert. Yeah, that's a good qualification there. Yeah, and so the difference between resolve and return is that, yeah, so with resolve, that result is kept as like the gospel truth and is passed down to the alert, but the rest of the code still runs. It's just ignored and we don't care about it. But with a return, it's true. Yeah, it's like a break. It just kicks you out of the function immediately. Yeah, that's a good clarification there. Yeah, so you have to, and Senior K has another good point there. Despite it resolving only once, it doesn't mean that the function exits. So you have to be careful not to put code after resolving and then expecting that code to be executed. Yeah. Mm-hmm. Good point. Okay, so that was task one. Let's go ahead and do task two. Good job, everybody. All right, so delay with a promise. The built in function set timeout uses callbacks. Um, Okay, create a promise based alternative. The function delay should return a promise. That promise should resolve after ms milliseconds so that we can add then to it. So, what this is doing is um, it's basically saying, all right, so we have this function here, and then when they call it, we want to pass in a delay of 3,000 milliseconds, have that be part of a promise, have the promise be fulfilled, um, after, and then essentially alert after the promise is fulfilled. Yeah, so we want to be able to chain a then, and then have that then alert that message there. So essentially, we want to just build a new promise. Um, Okay, so they're really telling us quite well what to do here. So they say return a promise, right? So we're going to return, and then, oops, sorry, I'm trying to. Oh, I can't write in here. That's right. I always forget which. I forget. So some of the homeworks, some of the text you can actually type in like eloquent JavaScript, and I always forget which ones you can and which one you can't. So let's get this, and we'll do it in the console. Mm-hmm. Okay. Oops. And I hit enter too. All right. Don't hit enter in the console. All right. So we're going to return, right? They're telling us to return something. So how do I declare a new promise? Yeah, new promise. Easy question, right? All right. So new promise, and um, essentially we we don't, there's never a point where this promise is ever going to give us an error, nor do we want it to ever give us an error, right? It's always just going to resolve after, it's always going to resolve successfully after whatever delay we pass in, right? So essentially, we don't need the reject parameter. We can just say resolve, and that is an arrow function. And then they've told us, I believe, that we need to use set timeout. So the built-in function set timeout uses callbacks. Create a promise based. Okay, so we need to call it set timeout. Set timeout. Timeout. And what we're going to pass into set timeout is essentially the result that we want, which is resolve. And if you've ever used set timeout before, essentially you pass in the thing that you want, the result that you want to happen, and then you pass in the delay. So in this case, we're going to pass in, we say that what we want is a resolution, and we're going to pass in a delay. Get my parentheses right here. Okay. So essentially, what it's going to do is it's going to wrap that into a promise. We can pass in a delay, and it's going to wait 3 seconds, resolve the promise, and then run an alert, theoretically. Yeah. So do you see that? You see where it says promise pending? It told us that the promise was waiting to be resolved, and it was waiting 3 seconds to be resolved. And then, only then, after 3 seconds, it ran the alert. Yeah, kind of neat. So it's interesting it doesn't update the, oh, and then look now, check it out. So it said pending originally, but now after I close that alert and I expand my promise, you can see it says promise state was fulfilled. The promise was fulfilled. It finished successfully. It resolved. But again, the promise can be fulfilled whether it was so the promise can be settled whether it resolved or rejected. But in this case, it did resolve. So so it was fulfilled successfully. Yeah, kind of neat. Now this one is more involved. This third task is more involved. It's like the CSS hidden class. Delay is such a common promise to make. Yeah, yeah, delaying is very common, and you can use it for a lot of things. So we've used it several times. We've used it. The most recent time we used it was in Snake. You remember? If y'all were on my Snake stream, we used timeouts to essentially make our snake longer. So we use the timeout to essentially say increase the delay before we erase the last segment of the snake's body, so it appears to be longer. It's drawing across the screen, and we delayed that erasing of the snake's body. So yeah, delays can be very useful. All right, so animated circle with promise. Rewrite the show circle function in the solution of this. There's a previous chapter on animations, so that it returns a promise instead of accepting a callback. Okay, so and then they give us basically the new usage of that. So I already have the solution of the previous of that previous exercise pulled up because obviously we didn't do it right. So I went ahead and I grabbed that solution, and we can mess with it in their sandbox here. So let's see what it does first. So it gives us a button. We click that button, a circle expands, and then inside of that circle we get some text, right? So let's take a look at what this is doing. So I'm going to scroll down. They have everything in the same file: the HTML, the CSS, and the JavaScript, all in the same file. Shame. But let's look at the function. So we can scroll down here. I don't know if can you guys see that? Okay, I can make it a little bigger if we need to. Zoom in a little bit more, I think. Let me see. Yeah, there we go. That's a little bigger, maybe. All right, so we have yeah, we have a function called go, and I believe that's so yeah. So the function called go is called when we click on this button. So that starts the function, which then calls another function called show circle. So essentially, this go function is just wrapping this additional show circle function. And let's look at show circle. So show circle gets several arguments passed into it. It passes in 150, 150, 100, and then the last argument is actually an additional function that's doing a couple things. It's adding a class list and it's appending something. So um, JavaScript.info is really concerned about bounce rate in the exercise. Yeah, they got that Amazon streamlining going on, like y'all said. Yep. No separation of concerns. I know. Leon be out here shaking his head, right? Um, Yeah, so this show circle takes several arguments, one of which is actually an additional function, right? Um, so let's look at show circle. So what is it? What are its parameters? So that 150 is the CX, that other 150 is the CY, the 100 is the radius, and then this last big old nonsense here is actually the callback. That's the thing that we're going to do. That's the thing that this function is going to set in motion once it's finished executing. um Dry like sand. Yeah, it gets a little this is where it gets a little bit more interesting as we get a little deeper into it. I know this first stuff is like right. But it's important to know the terminology, so that way when you hear it, that you can be like, oh yeah, I know what that is, right? All right, so pay attention to this callback here, because we're going to need to edit it to make this compatible with promises instead of callbacks. So this is doing a bunch of stuff, blah, 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 blah. And then basically after it's setting up all the characteristics of the circle, we have a timeout. And it's basically, that's what's allowing the circle to kind of expand. And then at the very end, we are adding a couple of event listeners, we're removing an event listener, and then we launched our callback function, which is goes back, calls back, right? That's think about the word call back to what we passed in up here. And the very last thing this does is it waits until the circle is finished growing, and then it says it adds this additional class list class to the class list, and it appends the words hello world. So that's why the words hello world don't trigger until after the circle is finished expanding. Okay, so that's the baseline. Now we basically have to edit this to use promises instead of callbacks. Okay, so and I got to use notes for this because I can't do this from memory. So give me a sec. Oh, no, hang on. Okay, so oh, and let's get the new usage as well. So show circle so we can see that the show circle has now been modified to have a then. So we're going to make show circle, essentially we're going to make show circle into a promise in order for us to be able to chain a then afterwards. So since instead of a callback, we're basically going to turn show circle into a promise so that we can use then to only add the hello world text once that circle promise is finished executing. Okay. So essentially what we want to do is we want to replace what was there with this. Okay, and that's all well and good, right? But now we have to essentially turn show circle into a promise. Okay, so how do we do that? Well, essentially, we only want that hello world text to appear once the circle is finished growing. Now, what controls the what part of this show circle function um, essentially determines when the circle is finished growing? What part of the function says, all right, circle, start growing and then finish? Anyone know? So Go actually just launches the whole sequence. Um, yeah, yeah. Um, Yeah, so you guys are on the right track. Yeah, so essentially the timeout is what's sort of stopping and starting that growth, right? So um yeah, so the timeout is sort of the crucial part of this. And so what we're going to do is we can just wrap this timeout into we can wrap this timeout in a promise. So essentially we can say return a promise so that we can then use then so that we can then use then and um, attach the additional text that we need. All right, so we're going to return a new promise, and we always want this promise to resolve. So the promise is always going to resolve. So we can pass resolve into our promise. I'm going to get my parentheses sorted out here, and then essentially once that promise is resolved, then we want to do the rest. So you put the resolve in where the callback, yeah, exactly. Yep. We're going to replace the callback with the resolve. Yep. I think I'm missing a parenthesis. It ain't automatically, but it promisify. And yes, that's the actual word. And that there's a whole section in the chapter about it. Promisify is a fun word for making non-promised things promises. Yeah, exactly. Yep. So we're wrapping it in a promise. We're saying, all right, once you're done with this promise, the next thing you want to do is resolve to div. And if we recall, div was the thing that we passed in to the then. JavaScript is so ridiculous. Yes, it is. Oh, and here's my dog. He says hi. You can't see him very well, but yeah, he's here. He's trying to tell me it's dinner time. Yeah, so we'll finish this and then we'll take a break, okay? It's a good. Yeah, he's got his head in my lap right now. Yeah. Okay, so let's see. I think I may be missing a parenthesis here. Um, 1 second. Yeah, I'm missing the close. So let's see. Timeout. I think I need. Yeah. I didn't close my resolution. I don't think. Yeah. Resolve. Resolve. Yeah. Okay. I'm missing my brackets. Yep. You got it. Thank you. Yep. So I'm missing a bracket there on resolve, and then I need to close both this parenthesis and the other one. So I need them right here, I think. Thanks for catching that. Yeah, so that closes that, and then that closes that. So should be good to go. Let's try it. We'll see. 50-50. No errors. Hey, there we go. All right. So essentially, what we've done is we've just kind of promisified. We've promisified an older callback function. We've wrapped it in a promise and then set the resolution to essentially call the next thing in the chain. Sorry, this was mentioned before, but maybe so on line 45. Let's look at that. Yeah, so if you recall on in the definition of a promise itself, the basic definition of a promise, let's go back up here. Yeah, so in a basic definition of a promise, we can have a resolve and a reject. But in this case, we know that our promise that we're setting up is never going to have we're never going to reject. It's always going to resolve successfully. So we don't have to pass in both resolve and reject um, as as you know as these potential arguments. We're just going to pass in resolve. Yeah. So we're just going to say, yep, it's always going to resolve. That's all we need. And then the result of that resolve is going to move on to div. Yeah. So this probably would have been more fun if we'd have actually done the original exercise, but we didn't. So here we are. But hey, we did it anyway, right? Sometimes you just got to power through. Rascal says, recently had to promissify the event-based speech recognition API. Oh my goodness. For my tic-tac-toe. I spent 20 minutes just throwing so many console log and resolves everywhere. Like, where do you end? Trying to figure out where that actually ended. That's funny. And also too, go subscribe to Rascal on Twitch. I think I called this out before, but Rascal has started streaming now. And so if you want to get some of that Rascal goodness in stream form, go hit him up on Twitch. I don't have the shout out thing, but you can just, I mean, their name's right there. So hit him up. Hit up Rascal on Twitch. Okay. When we come back from our break, we're going to let's go back. I think this is all the tasks. I think we did it. Woo, comments. All right. Yeah. So when we come back, the next thing we're going to take a look at is chaining promises. And we've made references to this before. But talking about like having multiple thens, so creating a sort of a chain of tasks, right? And so the next thing, yeah, the next thing we're going to do when we come back is we are going to talk about chaining, and then the thing to me, the thing that kind of helps tie it together better is when we talk about error handling. So we pair our chaining with error handling, and it kind of starts looking more like what we're used to seeing when we have already started fetching from APIs. You see like you can have multiple thens, and then you have a catch at the end to handle any exceptions. Yeah. Yeah, and Rascal, I went back and I watched a little bit of your VOD. Rascal did a really cool thing. They built a tic tac toe that allows for speech recognition using a Chrome API that does like native speech recognition within Chrome, which I think is pretty rad. And I think it may be actually what the stream closed captioner uses. I haven't really dug into it, but like the stream closed captioner that I use and that Leon uses and that other streamers use. I think it may use that as well. I'm not entirely sure. But yeah, it's pretty cool. So check out their VODs. All right, let's get the timer on for 5 minutes and we'll come back and we'll do some more. All right, 5 minutes on the clock. I'm going to feed my dogs. I will see you back here shortly. All right, come on back, come on back. About 1 minute warning. I'm gonna mute the timer so it doesn't beep in your face if I forget to stop it. I just got to make sure my young dog doesn't eat my old dog's food. So I gotta be the sheriff a little bit. I'll be back in a second. That's how it's so funny how the timer acts like it's paused at like 1 second. I don't know why it does that. It's not that way on my screen, but it looks that way on the stream. Okay, let's get back to it. All right, so let's take a look at chaining promises. Um, so when we mean chaining promises, you might have heard, the phrase of chaining before when you talk about like methods, right? So like when we're doing like all sorts of funky stuff with strings and arrays, we can chain various methods together to do something in sequence, right? So if we think about like messing with a string, kind of like we did for the Pokemon. We did basically, we can split the string into an array, do some array methods on it, and then rejoin it all in one line by chaining methods. Yeah, Russell, I think that's what's happening here. Is that there's some kind of weird stream thing that basically if I don't move the mouse, then it doesn't actually update the screen. So that's super weird. But yeah, so you can do the same thing. We can do the same thing with promises where we can execute things in sequence after that promise is fulfilled or settled, to execute various functions in order. And here's an example of what that chaining might look like. Um, so in this case, what it's doing is it has a promise and we're setting a timeout, and it's going to resolve with a result of 1 after 1 second. And then the next thing it's going to do is it's going to alert the result, which is 1, and it's going to return the result times 2. So what is that going to do? It's going to essentially pass result times 2 into the next function. So it's going to pass it down the chain. I didn't hear my webcam on. I'm sorry. It's going to pass that result back down the chain, just like it would is if we were chaining, methods together, like to mess with a string, an array, right? The result gets passed into the next thing. So, and that's exactly what's happening here. So the result is passed through the chain of then handlers. And we just talked about the flow. Mm. Hello, flow. We just talked about the flow. Now we're talking about flow, the happy tree. Yeah, we talked about you, flow. Yeah, exactly. um, yeah, and so that's the correct execution, right? Is chaining on a single promise. And then they show there's a potential of, a potential issue might, a thing somebody might try is, instead of chaining, attaching separate thens to separate instances of the promise. And of course, that's not going to work because we're just recalling the original promise every single time. Yeah, Linda, I am recording. My VODs record automatically, and you can find my VODs on my Twitch channel for up to 60 days. And then after 60 days, I move them to YouTube, or well before 60 days, I move them to YouTube, and you can catch them there as well. So no problem. There's never any problem if you can't catch me live. You can always hit up the VODs. Yep, VOD is recording. Absolutely. Check out my Twitch, my channel homepage if you want to see some VODs. Um, okay. So yeah, what we did there instead of chaining is sending multiple handlers to one promise, so they don't work in sequence. So I think we can kind of understand that intuitively by thinking about how familiar we are with chaining methods on like a string or an array, right? We've done that a lot, especially for Code Wars. If you want to get those one-liner solutions in Code Wars, you gotta chain your methods, right? Oh, hi, Pink Star. Welcome. How you doing? I like the emoji storm there. Very nice. Yeah. Good to see you. Yeah, exactly like on Code Wars Flow. Yep, got to chain your methods. Um okay, and so then you can inside of a then. So you start with a promise and then you can chain thens onto that promise, right? You can chain multiple then statements onto that promise or then methods onto that promise. Um and then also you can call additional promises inside of that then, and now that might be useful, right? So think about when that could be useful is if you are, for example, maybe doing like a fetch, and then you want to take the result of that fetch and get something out of it and then call an additional fetch later on. But you need the result of that first fetch, right? You need that to resolve, you need that to be done to get the data back, and then maybe you want to then use that result and call an additional fetch based on something in that result. Like we could have used that for the Pokemon project that we did on Sunday, right? Instead of doing like totally separate fetches and separate functions, essentially we could have probably nested those together a little bit more efficiently doing something like this. So yeah, so you can have additional promises declared inside of a then statement on an original promise. And I think we did talk about that a little bit. We did think about doing that. It would have been a little bit cumbersome given all the operations that we had to that we had to do on that fetch. And so it's really kind of a judgment call. Yeah, this also results in just a sprinkling of encapsulation, and the data and promises are combined in their own little scopes. Yep, exactly. Yeah. And so yeah, Flo, since you just got here, yeah, so a promise is basically like saying we have some code that we got to execute, and then we have some additional code that relies on the results of that first code's execution. um, and so we what the promise is kind of like the mediator between those two, and it says, all right, consuming code, you need to wait for a hot second until this promise is done running, and only then do you get the result and then start executing, because otherwise that code may both sets of code may try to run synchronously or together with the consuming code executing before it has all the data it needs to run successfully. So we're forcing an order of operations here. Yeah. We're forcing order of operations. We're forcing our code to run in a logical order so that it can be successful. Um, yeah, and so here we're showing that yeah, Vera's doing some code work. Verola Fox was doing some code wars, weren't they? Uh, oh, so we could do that instead of a button. Like the button makes it so the code didn't try to process before you use it. Yeah, yeah, yeah. And we're actually gonna I think we'll see an example of that a little bit later, using like a while loop. So essentially, we'll have like a while loop that runs until it gets a valid result, and then and then we'll have a series of then statements to essentially control the flow of the code after that. So yeah, it's you could do that to basically um, force like an order of operations instead of doing it manually with like a button. Yeah, there's I think there's all sorts of potential use cases for this. And I was saying earlier that I'd actually used promises I'd used promises once before without even knowing really what they were or how they worked, just because that's how I do things. I throw stuff at the wall until something sticks, right? I'd actually used a promise before. If you go back and look at my Jeopardy stream, I used a promise because I had to make like 5 simultaneous fetches to the Jeopardy API to get all the categories for my Jeopardy board. But I didn't want the board to try to populate until I had all the data for the board. I didn't want I didn't want it to start trying to populate the categories until I had all the categories to fill it. Um, and so I used a promise to say, all right, you got to finish all 5 of your fetches before you can try to start building the board. So don't try to start building that board until all the fetches have returned their categories back. And so I used a promise to essentially say, all right, hold up, wait on that for a hot second. And then once you have all the categories, then populate the array and do all the rest of the stuff. So it can be useful for stuff like that, where you have a lot of things you got to get done to make the rest of the code successful. And they show an example there. We're gonna kind of skim this. Let's see. Then okay, yeah. So let's look at fetch. I want to go straight to fetch because we've done fetches before, and we kind of know how they operate, right? We know that if we go to if we can fetch a URL, get a result, parse that result, do stuff with the result, and then catch any errors, right? So we already kind of intuitively know how those work. So we're going to look at fetch as an example of this method chaining. So in front-end programming, promises are often used for network requests. Don't we know it? API requests, right? So let's see an extended example of that. We'll use the fetch method to load the information about the user from the remote server. The basic syntax is quite simple, right? Promise equals fetch. This makes a network request to the URL and returns a promise. The promise resolves with the response object when the remote server responds with headers, but before the full response is downloaded. And to read the full response, we should call the method response.text. And in our case, I think we usually use response.json, but either way. Oh, yay, prophecy. That's awesome. And prophecy, if you're talking about like the promise all, like doing multiple fetches and then and waiting till all those fetches are resolved, stick with me for a little bit because we're going to touch on that specifically, the various ways that you can resolve multiple promises. Like do multiple fetch requests and wait till they're all done, or wait till any one of them is done and then do something else. Or any one of them is successful. So we're actually are going to touch on that specific thing a little bit later. I just wanted to touch on it now to give you a feel for some real applications of this kind of thing. Yeah. Okay, so here's a fetch. And we've seen this sort of thing before, right? So we do a fetch, we have a then, we get the response, we take in the response, and essentially within we return the text of that response. And so essentially, so we call the fetch first, right? The then runs as soon as the remote server responds. And then response.text returns a new promise that resolves with the full response text. So we have a couple promises here, right? The first promise is fulfilled as soon as we get a valid response from the server. Server says, hello, I'm here. Promise is fulfilled. We're done. We move on to the then. What the then does is it says, all right, new promise. I'm not going to be fulfilled until I get back the text from that server, because we already know the server is working. So now we can grab the result. Cool. Then resolve that and return the text. And then finally, we can do stuff with that text, right? Or whatever we get back, whether it's JSON or text or whatever. The stuff we get back, the meat that we get back, we can do stuff with it. Okay. And this may be more of what we're used to seeing, right? We do a fetch, we get a then, we get a response, we grab the JSON, and then we do stuff with it. So yeah, that's basically what we're doing. We're using a series of promises to force our code to execute in the proper order to get a valid response back from the server. Okay. So here we can kind of put that in practice. What we're going to do is we're going to essentially make a request for some JSON about a user. We're going to parse that JSON, and then we're going to do another fetch. So we're going to get back. We're going to get some user data. We're going to get a username. We're going to get some user data in general, and then we're going to go ahead and take that user data and we're going to pass it into the GitHub API right here, and then we're going to get back some data from the GitHub API, and then essentially we're going to grab that person's avatar and we're going to add it to the document body. So it's kind of cool. We're doing a fetch, getting something back, doing another fetch based on that first fetch's data, and then doing stuff with that resulting data. Yeah, so let's see if we can run this. I don't remember if this works or not, but we'll try it. That's essentially what it's doing. Hey, whoa! Did you see that? I'm gonna do it again. I gotta move my mouse, otherwise it doesn't work. Hang on. Look at that. Doop. And then the cool thing is that they have a timeout, and so then it removes the image after 3 seconds. Yeah. Yeah, so it's nice. I know. I think that's pretty cool. So yeah, it's doing, forcing an order of operations, forcing a logical order of operations from this code. And then they say, all right, so this code does work. However, there's a potential problem in it, a typical error for those who begin to use promises. So if we look at this timeout line here, excuse me, how can we do something after the avatar has finished showing and gets removed? For example, we'd like to show a form for editing that user or something else. As of now, there's no way. So essentially, after this final then, we aren't returning anything. We aren't passing anything. There's nothing to pass into a next chain. So what do we do? To make the chain extendable even further, we need to return a promise that resolves when the avatar finishes showing. Because remember, each then is only triggered once the previous promise has been resolved. So for each line of this then, there's a promise that gets settled. And then it goes on down the chain, right? Except for this last one. With this last one, there's no promise. We're just doing stuff with it. Which is kind of how we've done in our API calls so far, right? We have the first two, which are promises, and then we have a bunch of stuff that we do, and then we're done. And the fetch is over. But in this case, what they're doing is they add a timeout, and then they add a resolution so that then we can trigger additional thens and continue the chain if we would like to. So let's see how that looks. Let's run that. So remember, all they've done here is they've added this additional timeout with a resolution, which then allows us to continue the chain. So, all right, so avatar shows up, and then after that, we get an alert. Finish showing Ilya Cantor. And after we click OK, the avatar and the alert both go away. So that is the then handler now returns a new promise that becomes settled only after the call of resolve GitHub user in the set timeout. The next then in the chain will wait for that. As good practice, an asynchronous action, so like a then or something like that, should always return a promise. That makes it possible to plan actions after it. Even if we don't plan to extend the chain now, we may need it later. So in this case, what they've done then is finally, and I think this is kind of like a missing link of something that I needed personally, because I always felt weird about having these fetch requests where you have multiple thens, and it just makes the fetch like massive. right? You just end up with like a massive fetch, which is way too long. And so this I need to kind of like internalize this a little bit more, but knowing that I could potentially split these types of things, these types of asynchronous functions into like multiple functions, makes a lot more palatable for me personally. DriveNet, oh cool, I wish we'd started with it. Yeah, I think it's important to know the basics of like what a promise is and what a callback is, so that way when you see them you know what they are. But I understand, yeah, like this looking at fetches specifically is what we're more familiar with just based on what we've done hands on so far. So yeah, I totally feel you. Um, okay, so what is this doing? All right, so our first function is just load JSON, and it's doing a fetch, and it's parsing the response. And what it's doing then is it's returning essentially the results of that fetch. And so in the end, it's returning the response, the JSON response. And so what are we doing here? So the next function, it is essentially calling that load JSON function. It's passing in the URL and then the name of the user that we pass into that. And then the third function, show avatar, is declaring a new promise. It's doing the timeout, and let's see, where is the oh yeah, and that's just setting up that show avatar. So and then in the end, what we're doing is we're calling load JSON. All we need to do is pass in the URL, and so then what happens? We pass in the URL. It does the fetch, right? And then we pass in a user, and we get all the information about that user. Then we show the avatar, and then we as soon as that GitHub user is like, as soon as that avatar has been up for 3 seconds or whatever, we send an alert saying finish showing GitHub user. So in the end, our actual chaining, like the actual chaining that we're doing, is only 4 lines, which I think to me is a lot cleaner and easier to follow, because we're kind of doing all the functional stuff off to the side, which is kind of what I was trying to do with my Pokemon app that I made. It wasn't as good as, like, I didn't have quite the grasp of it that I needed at the time. Yeah, it's much crisper, it's much cleaner. But what I was trying to do with my Pokemon app was something similar, is keeping the actual code itself out of my out of my thens, and only executing functions inside of my then statements, or inside of my thens. Which I kind of did, kind of didn't, but it was partially successful. But it's good to know what I was trying to do was hopefully similar to best practice, just because I wanted it to look nice. Yeah. So you get all the gnarly calculations and fetches and calls and stuff done out of the way, and then when you actually start chaining them together, you make it very clean. So, yeah, that's the goal. All right. So a little summary there. Um, so the first task. This kind of tests our basic knowledge of what chaining is actually doing. Um, oh, Strange Shadow Song says, I got into that million then hell trying to call 2 different cocktail DB APIs in sequence. Yeah, this helps to picture how it can be done without it getting all gnarly. Absolutely. Yeah. Yeah. Yeah, this was that just that little example there was very helpful to read. Okay, so let's look at this task. Are these 2 code fragments equal? In other words, do they behave the same way in any circumstances for any handler function? So the first one has a promise, so we don't have to know what the promise is. It's a promise, right? So we know we can chain some stuff to it. So first we have a then, and then we have a catch. The next thing is a promise with a single then that executes 2 functions. So do those behave the same way at any point? Averagely sized rabbit. Dang, I'm late for promises. I guess I wasn't awaiting. Yeah. Yeah. Averagely sized. We actually just did a really cool example of like looking at chaining methods when in doing multiple fetches. So if you're struggling at all with APIs, and like doing multiple calls to an API in sequence, once the VOD comes out, I'd suggest maybe rewinding a little bit and catching and catching that example, or looking at it yourself. That's fine too. Okay, so anybody know, are these code fragments equal? Do they do the same thing? Are they going to behave the same way? Any guesses? Any takers? I'm going to hydrate. No, Terracer. Terracer filling the silence there. You're gonna say no. All right, no. Let's gamble on bet. All right, yeah, no problem. You're allowed to gamble. It's all right. Yeah, Terracer coming in hot there. Yeah, right, exactly. So, and Tony Stark as well. Yeah. Um, so by nature, the way the chain works is it resolves what's happening in the chain item. So in this case, it's going to resolve whatever's happening in the then, and then it's going to pass that result down to the catch. So in this case, the like if there was an error in this then statement here, then it will catch in the catch and execute F2, versus in this one it'll just do everything in the then, and there's no error handling that will actually handle if there is a problem in this then statement. There's nothing to pass down the chain. The chain is done. So if we just look at the solution here, so they are not equal. The difference is that if an error happens in F1, then it's handled by the catch, which is essentially what Tony Stark and Tercer said, right? But in this case, F1 and F2 are in the same chain member of the chain, right? An error is passed down the chain. In the second code piece, there is no chain below F1, right? Okay, so that was the only task on this chapter. We talked about a whole bunch, but they didn't put any tasks at the end. So, but I do think it's worth talking about, especially with the API related stuff. And we're gonna cover more API stuff. Oh yeah, Rascal, thanks for linking the VOD there. Yep. Florence, is one best practice. Well, we're going to talk about that in the very next chapter, actually. So hold that thought. The very next thing we're going to talk about is error handling. So what catch is for and why you use catch. That's the very next thing we're actually going to talk about. So hold that thought for just another minute. All right. So let's talk about error handling with promises. Okay. So, essentially answer to yeah, yes, it was all intentional. Yes, just helping with the transition. Yes, exactly. Florence is out here like, just come on, move it along, move it along. Okay, so promise chains are great at error handling. When a promise rejects, the control jumps to the nearest rejection handler. So what I think of it is like, I imagine, so think of it like a factory. In a factory, you might have like people doing like, there's a conveyor belt and there's an inspection line, and you've got like people, inspecting a thing, and if it looks good, they pass it on to the next person in the line who inspects a different thing, and then if that looks good, they pass it on and they inspect a different thing. But if something is wrong at any point, I just imagine the inspector picking up the object and just chucking it into the nearest trash can, like just overhand, Kobe dunk into the nearest trash can. And any of the inspectors that fail an object, they're going to all chuck it into that trash can. And so that's why we want to have some kind of catch to be that trash can, to be that handler, that thing that's going to handle rejection. You got to learn how to handle rejection in a healthy way. You got to understand. You got to handle rejection. So that's what we're going to do. Okay. So for instance, in the code below, the URL to fetch is wrong, and catch handles the error. So in this case, there's no server. and so there's no response to parse, so it gets rejected, so it hits the catch. And so the catch then doesn't have to be immediate, which we've seen in our API calls, right? We have seen how we can have multiple thens, and then we can just sort of we can put our trash can at the end of the inspection line, and everybody can still reach it. You can still, do an overhand toss into the trash can. Yeah. So in this case, we have like one, two, three, four then statements, and then we have a catch at the very end to handle all the errors. And normally such a catch doesn't trigger at all, which, if you've done multiple API calls, you might not see that catch trigger. But if any of the promises above rejects, so at any point in this chain, if the thing we're doing is bad, we just toss it and we go straight to the trash can. And so the code of a promise executor and promise handlers has an invisible try catch around it. So if an exception happens, it gets caught and treated as a rejection. And so this is just semantic differences. You don't have to explicitly say reject when an error occurs. At this point, the throw it can automatically say, all right, error is bad, go to the catch instead, and alert the error. So if at any point inside of a then, if you want to make sure that a given condition will throw an error and go into the catch, you can do that sort of manually. So in this case, if you can say throw new error and make that error specific. So if you're having an issue with maybe a cryptic error or something like that, you could always say just throw new error and make that error text specific, and it'll chuck it to the catch. And this happens for all errors, as I'm sure all of us have seen at some point, right? You wrote an API call, you screwed something up, and you learned how that catch actually works. I know I've done it. This happens for all errors, not just those caused by the throw statement. For example, a programming error, which I think is far more relatable to all of us. Florin says, "I would like to meet a CSS expert if this unicorn exists." Yeah, I don't know. There's only one or two that I've seen on the Discord. Miracle's pretty darn good. I think they took a bit of a hiatus, but I think they're back now. Miracle is really really great designer. Yeah, I always appreciated learning from them. There's a few folks around, but CSS is a heck of a beast. Okay, so we can have as many then handlers as we want and use a single catch at the end to handle errors in all of them. I think that's pretty clear, right? So but you can recover from an error. So if you throw, so I love this. If you throw inside catch, so throw and catch, then the control goes to the next closest error handler. And if we handle the error and finish normally, then it can continue to the next closest successful then handler. So here's an example of actually continuing on after you hit that catch. So that can be a way to continue on when things maybe don't go quite as expected inside of your promise. So here we have a new promise, and at one point we throw an error. Whoops. And so we hit the catch. We complete the catch. We throw an alert. That's all we wanted. And then we can continue with the chain. We can keep going. There's nothing, the catch doesn't have to be the end. But I mean, it can be, and generally it is, but it doesn't have to be. Yeah. So, and here's a case where the 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 first catch handler doesn't exactly work as expected. So, what's happening here? All right, so we have a new promise. We throw an error. And so, all right, it says, all right, I'm going to go to the nearest catch. Remember, it's going to go to the nearest catch. And so in this case, the catch is the very next thing. So it says, all right, we're going to go into this catch. And it says, all right, if an error is an instance of this particular error type, which in this case it isn't, so we'll run this and we'll see it. But in this case, the error is not this type of error type. So it says else alert can't handle such error, and it's going to throw another error. So we threw an error, we went to the catch, it couldn't handle it. So the catch itself is going to throw an error. And so it's going to go down to the next nearest catch, and it's going to see if it can handle that. So in this case, this catch can handle it because it says an unknown error has occurred. I need to sneeze, excuse me. All right, there we go. We're back. Hey, Cybersword, welcome. Hey, yeah, we've been going since about 7 p.m. Eastern, so about an hour and 45 minutes, but that's what the VOD is for. You can always go back and watch the VOD. There's no problem with that at all. That's why I record them. So feel free to go back and watch. Hey, locating. So have you been following along with the 100 devs cohort? Are you a member of the cohort? So let's run this and let's see what happens, okay? So what do we get? Okay, so the first thing, so what do? The promise threw an error, right? So we hit the catch. We hit the first error bucket, the first error trash can. We went in there and said, all right, is the error an instance of URI error? It is not. Or URI error? It is not. So we hit the else statement and it threw this alert that says, can't handle this error. I don't know what to do. Help. So it's going to throw an internal error, and then it's going to go down to the next catch. So what are we going to get? We're going to get another error message saying that an unknown error has occurred. Whoops. Yeah. So it's just jumping down. It's just jumping down. Hey, Jabalicious, welcome. How's it going? I don't know that we've gotten a raid from Jabalicious me before. Welcome. Hi. What were you working on? We're learning about promises and asynchronous functions today. Yanzor, hey, welcome, welcome. Pain and misery, oh my goodness. Hey, welcome, welcome. Okay, so that's just basically saying how that, how catch doesn't have to be the end, right? If you could potentially have multiple catches to catch and handle different types of errors at different points in your promise. So if one catch can't handle it, it's going to throw it down. It's going to throw that error down to the next catch. Should I use the May 17th do homework, the async await Mozilla read? Well, so this is the push homework locating. So if you want to, this is the homework. This is push homework for this week. So I mean, you're welcome to watch. I'm never going to say you're not allowed to stay on the stream, right? You can always push. Well, so averagely, I think it depends on what you're trying to get. So if you're trying to do multiple fetches that rely on data from the previous fetch, um, if you're trying to do multiple fetches, like you have a first fetch that gets some base data, and then like in the Pokemon app that we did, the first fetch got some base data that contained a URL that we needed to use for a second fetch to get some more data. So we needed that first fetch to be totally done first, so that because the second fetch relied on that, and so that would be a good case for that chaining. However, averagely, if you're doing fetches that are independent of each other, you might want to use promise all, which we're going to get to a little bit later. So it just depends on are you trying to do multiple things at the same time or trying to do multiple things in sequence. It just depends on what you're trying to do. Oh, that's a good point, D-Rox. Yeah, so you can throw the existing error or a new error. So in this case, this case just passed the existing error. So yeah, so we threw a new error. We passed it into here. and it couldn't handle it, so it tossed it it tossed it down the line to the next catch. That's a good point. Yeah, it wasn't a new error, it was the same error. Yeah. Okay. So we've talked about, oh, I need to close my alert here. Sorry. We've talked about handling exceptions, but what about unhandled? So what if we don't add a catch? And I've seen that sometimes, just not adding any catch at all. So what happens? Um, so in case of an error, the promise becomes rejected, and the execution should jump to the closest rejection handler, but there is nowhere to jump to. There's no catch. So the error gets stuck, and there's no code to handle it. Um, in practice, just like with regular unhandled errors in code, it means that something has gone terribly wrong. And I think for a lot of us, we get unhandled errors a lot, right? It's just a fact of life. So it's all good. When that happens, the script will die with a message in the console. Um, hey, Jabalicious, want to raid me real quick and throw some support? Thank you so much. You're coded out and your smooth brain is tired from straight. Hey, that's no worries at all. You gotta take care of yourself, right? So do what you gotta do. Yeah, the VODs are always there. You can always come back and watch later or pick it up on YouTube. It's all good. Thanks again for the raid. Much appreciated. Um, okay, so this just talks about like unhandled rejections, but I think we're kind of familiar with unhandled rejections, right? We've seen them a lot. So basically, if you don't have a catch, you don't have a way to handle that error, and so it's just going to print to the console. Usually, such errors are unrecoverable, right? We have to generally, when we hit one of those types of errors, we have to reload the page. So it's better if we can find a way, if we can use catch to instead maybe handle those errors and see if we can punt them downstream and maybe continue the chain and get around it a little bit, so we don't have to keep reloading the page and starting over. So that can be a useful use case of catch that I don't think a lot of us have probably utilized before. Okay, so in summary, a catch handles errors and promises of all kinds. An error in programming, an intended error, an error that we manually throw, whatever. Catches can be great ways to gather those errors and do something productive with them. We should place catch in places where we want to handle errors and know how to handle them. If we know, for example, that maybe an API is going to be flaky, or we might get it, we might have a service become unavailable periodically, then we can say, all right, well, we probably know how to handle that. We have a backup API that we want to hit instead, maybe, and so we can handle things that way. Well, I mean, you can log the error, yeah. And I think that's what we do in right now in most of our API calls, right? We do have a catch statement, but really all it does is it console logs the error. So if you so go back and look at like the API calls, the API template that we're using right now, and it has a catch statement in there. I think all it's doing is it's console logging that error that we get, so we can see it. And in this case, it's saying, best practice should probably be that then we have a final, we have like basically a final bucket for unhandled rejections. And so if something completely unexpected happens and we don't have any way to handle it, we can track unhandled errors and inform the user. I mean, that's up to you. Yeah. Okay. So let's look at the task. Hey, Don, welcome. How you doing, Don? All right, so here's our task. What do you think? Will this catch trigger? So we have a promise, we have a timeout, and it's going to throw an error. And then at the very end, we have a catch that's going to alert. And theoretically, what this is trying to do is catch that error and alert it, right? Do you think the catch will trigger? Yes or no? What do you think? It's okay to guess. Take your bets. I should have a poll. It takes too long to set up a poll, though. I don't care that much. Any guesses? Okay, seeing no guesses, let's look at the answer. But oh, Rascal says no. Okay. All right. So yeah, this is kind of a weird one, right? Um, let's look. Let's see. So the answer is no. Good job, Rascal. Gold star. Um, so as said in the chapter, there is an oh hey Big Star. Thanks for saying hi. As said in the chapter, there's an implicit try catch around the function code. So all synchronous errors are handled. But here the error is generated not while the executor is running, but later. So the promise can't handle it. So essentially, because we put a timeout here, the error is not generated until 1 second after the code is finished. So essentially, what it's doing is it's that timeout is taking it out of the appropriate order of things. So the catch is already run by the time the error is actually thrown. So just kind of a weird little fake out. But yeah, in general, the thing to remember is that in most cases, um, catch can be very useful when you're executing things in sequence to grab errors and do useful things with them rather than just tossing an error into the console or causing the code to hang or throwing an unhandled exception. You can actually take those errors and do something productive with them, and maybe even keep your code going if you know how to properly if you kind of know what errors you're going to get, and then you know how to properly handle them. So I think that's the major takeaway here. This task is kind of like a little, I don't know, I don't really like this task. It feels like a fake out versus actually showing you the valuable ways that catch can be used. My opinion, though. It felt more like an eloquent JavaScript question. Okay. Uh it's 8:55. Let's go ahead and take our break now. Um and then we'll come back. I feel like this is a good, natural stopping place. And then we will come back and these next few Rascal. Yeah. So these two chapters here are going to go pretty quick. There's not a lot here. We actually already kind of touched on promisification when we did the little circle exercise earlier. So I think the two last major things that we want to talk about are the promise API and async await, which I think is one of the more important things that we're going to talk about on stream. So these two are the main ones. These two are kind of just not filler, but maybe not strictly, strong talking points. So just letting you kind of know what's coming up. These two are going to be the more important ones. So yeah, try catch or synchronous only. You'd have to put try catch in your timeout function for it to make any sense. Yeah, it's a weird question. I know. Yeah. All right. So let's put 5 minutes on the clock. Go get a drink, pet your dog, hug somebody, you know, whatever you got to do, and then I'll see you back in 5 minutes, and we'll get to the newest development of how to make promises easier to understand and easier to read, async await, which you've probably seen before and wondered what the frick is that. So we'll get there. Promises make me feel like I need to hug someone. Yeah, no, it's not easy. And I'm not saying like that I fully understand it yet either, but I think it's important to, like I say, it's important to expose ourselves to it now so that you have that little spark in your brain, you got that little seed, and you're going to be able to nurture that seed as we talk about it more in class, as we do more exercise with it. You're going to start to grow your understanding. And so that's why I'm slamming you into it now. All right. I will await you all to come back from break. Absolutely. Okay. Reset the timer and we'll get her going. And I will see you in 5. All right, don't worry. You still got 2 minutes left, so you still got plenty of time. Um, but I did want to show you guys. I know that some folks are struggling a little bit with the code and struggling a little bit with the concepts and stuff like that. So I just wanted to. I'm going to pull up. I foster kittens for the Humane Society, so I don't know if y'all want to see some pictures of cute little kittens, but um, let me get that pulled up. Yeah, I've fostered so many kittens, so many. So I've got kitten pics for days. All right, let me get it pulled up. So here's a couple of them. Show cats. Yeah. So that one there. That is let's see which one that is Juniper, and the little orange one there, that is Tulip, and then that one there closest to the camera is Ash. Um, and then sorry, I gotta drag it back over on my other screen to go. I don't want y'all seeing all my photos, but actually, I think if I've narrowed it down to kittens, so I think it's okay. Here, yeah, we can look at let's look at some kitten photos. We got kitten photos for days. Um, yeah, so here they were when they were a little smaller. And here's some kittens from a previous litter. These two were super fun. They're really great. And I want to show, oh, yeah, that's a good one right there. Yes. The real cutie there. And the cats are looking at you. They're jealous. There's my cutest kitten of all time. I want to show you my cutest kitten of all time. Then we'll get back to it. But hang on, I gotta find him. His name was Nugget, um, and he was stinking adorable. Hang on. Oh yeah, here he is. He looks like a cartoon. Little bug-eyed little. He looks so ridiculous. Yeah, that's Nugget. He was the size. You can see, like, look how big my hand looks compared to him. Look how big my hand looks compared to that little face. He was so small. He was the only surviving member of his litter, and he was tiny. And yeah, he turned in when he got bigger. His eyes stayed like just as big. He was like a little frog. Yeah, yeah. Okay, I think the timer's probably done. Yeah, timer's done, but that's okay. We were looking at kitties. Small cat, big N. Now my hands are pretty petite. So he was just a small little nugget. That's why I named him Nugget. But yeah, so I foster kittens for the Humane Society. I would highly recommend doing it. It's very rewarding, very fun, and I love all my babies. I could literally show you kitten pictures for like the next hour. I have so many. Oh yeah, here's another good one. Here's another good one. Look at that. Look at that little smush face. Look at that. Yeah, little fuzz bucket. And maybe I'll be able to show you some real kittens on stream someday. Um, my dog is a little bit too interested in kittens, so I don't. They stay in a separate room. But yeah, um, let's see, Nugget. Oh. Okay, I'm sorry. One more. You gotta bear with me. My most photogenic kitten. So like there's the cutest, which was Nugget, but then there's also the most photogenic. Like looks like a freaking like painting or something, like somebody's artist impression of a kitten. Look at her. Look at that face. I mean, for real. Look at her. Just the cutest. I'm loving the chat. Yeah. No, she was my prettiest little thing. But yeah, shelters always need kitten fosters, especially for moms with kittens. Um, and I mean, I know that there's always the question of, will I be able to let them go? But for me, like, it was hard the first couple times, but after that, you see, I've actually gotten to see several of my kittens get adopted, like, in person, and it's really amazing because you see that connection between them and their potential future owner. Um, and it's just the best thing in the world. So, um, yeah, so that was your little kitten time. And like I say, hopefully I can show you some live kittens on stream someday. Um, and that may be possible here pretty soon. I'm thinking about changing the location of my stream setup, and which may make it easier for me to do that. Oh, thank you, Ghibli. Oh, former animal shelter worker makes such a huge difference. Yeah, it absolutely does. And kudos for being a shelter worker as well. I know how hard that can be. So big big thanks to you. All right, I'll get my webcam going here again. We'll get back to it. Yeah, no, I actually, my babies that I have right now, they are so sweet. You just pick them up and they just go limp and they're just like, pet me. And yeah, they're such sweeties. So they're gonna be great little pets. Um, yeah, it's really rewarding and fun. I love it. And they don't take up any space either. Like, I mean, they can just be in a guest room or a little playpen or whatever, and so it's really nice. Okay, so we're gonna move on to Promise API. And here's where we're going to talk about some of those things that you all might find useful for some of your API projects. Um, your cat attacks me if you try to pet her. Oh my goodness. Yeah, some cats are like that. For all the kittens that I raise, I really try to make sure that they are as comfortable with handling as possible. But there's some kittens. I had one kitten. I don't even remember, he was little when I got him, so he was very impressionable and little, but he never mellowed down. I would pick him up and it was just claws in my hand. I at the time I was still going to the office for work, and I would have just massive, like, claw marks down my hand, and I was like, no, nobody's injuring me. It's just this crazy kitten that I have. But yeah, they all do have their own personalities, definitely. Um, Yeah, people look at you like, who did this to you? Yeah, exactly. Yep, exactly. Gotta, like, have band-aids all over and be like, it's fine. It's just a cat. um, okay, so promise all. Some of you might, this is what I used for my previous Jeopardy project that I did, and that some of you might find useful if you're trying to make multiple API calls at once and return those results. If I see babies were hilarious when you used to foster, just burrito roll them in a small blanket and they eventually go from to, oh, wait, pets are actually cool. More, please. Yeah, exactly. Okay, so let's say we want many promises to execute in parallel and then wait till all of them are ready. In the case of my Jeopardy stream, I wanted to wait till all the fetches were done and had returned their results before I tried to add them to an array. Um, so the syntax is literally let promise equal promise all. And it takes some kind of an iterable thing and returns a new promise. So the promise resolves when all listed promises, the new promise resolve when all listed promises are resolved, and the array of their results becomes its result. So basically, all that's saying is that you put a bunch of promises inside this larger group, and the large group only returns when all of the interior promises are done. So in the example of an API, once all the interior fetches are resolved successfully, then the end result is returned. So in this case, please note that the order of the resulting array members is the same as its source promises. So whatever order you pass in your fetch requests, that's the order that they end up in the resulting array. So in this case, what they're doing is they have an array of URLs. So these are all, distinct URLs requesting a different user from GitHub, right? Hitting the GitHub API, requesting a different user each time. And then what it's doing is it's mapping those URLs to a new array of fetches. So what you get then is an array full of fetch requests, right? And then we're just promising all of those fetch requests. I think when I did it, I wrote it out manually. I didn't loop it like this. I wrote out each fetch request, like 5 of them or 7 of them. I don't remember how many. I wrote out each one and wrapped those in a promise. But yeah, this is probably the better way to do it. Still, you can look at my code on my GitHub if you want to see what I did. Go to GitHub. GitHub. My username on GitHub is Mayan Wolf. If you want to look me up there, you can look at my Jeopardy project to see how I used promise all in that instance. Probably not the most efficient way, but it did work. So whatever. So another example of this is fetching user information for an array of GitHub users by their names. So in this case, they just pass in the names in an array, and then they map all of those names onto a fetch request that hits the same URL. So you could think of this if, like, for example, let's say you had, oh, thanks, Rascal. Let's say that you were trying to build an RPG, right? And you have an API that you're using that's generating certain characteristics based on, like, I don't know, um, like a faction or whatever. And so you could have an array with all of the faction names, and you could hit this API and essentially execute 10 fetch requests at once with each different faction name and get back all the characteristics at once in an array, which I think is pretty cool, right? So then you'd end up with an array of objects that have all the characteristics for all of the factions that you want all at once, ready to use. So I think that could be really useful. And so in this case, what they're doing is they're essentially doing a promise on all fetch requests, and then they are alerting the URL and the status, and then they're returning those responses. So they're passing them down to the next step. So basically, they're saying, "Yep, each of these executed, and here's the result." And then they are passing those into the responses, into an additional promise, mapping the JSON into an array, and then alerting the username for each. So let's run this and let's see if I don't remember if this one works or not, but let's try it. Some of these don't work. Some they URLs have changed or whatever, but let's try this one. All right, so good. Okay, so it passed in this name, Ilya Khan, and then it's returning the result. So we should get 3 of them. 1, 2, 3. And then the next thing it does is it's gone down through the chain, and it's actually grabbed the name of each user. So we've gotten all the way down here to the end of the chain, and we're alerting the name of each user. And then the chain concludes. But here's what's important about promise all is if any of the promises is rejected, the promise returned by promise all immediately rejects with that error. So all of them have to resolve successfully in order to get anything back, which is the crucial thing to remember about promise all, is that you're promising that all of them will work. So you have to kind of know that all of your requests are going to be successful before you try to do it on a whole big group. J.R. May Huber asks, how long your stream going to be? Well, I'm going to try to wrap it up probably around 10. We play things pretty loose here. But in general, my streams generally go anywhere from 3 to 4 hours. But in this case, I think it's going to be more closer to the 3-hour mark. Don't quote me on that, but that's just a guess, knowing how long the rest of these chapters are. Okay. Piece of Shoot says all and any or. Well, yeah, I mean, so there are, so we're started. The first thing we're looking at here is promise all, which means that all of them have to work. But there are other options as well, and we'll get to that in just a second. So if you think that maybe one of your fetches maybe won't resolve, then we have other alternatives that we can use. So in this case, the second promise is going to reject. This leads to an immediate rejection of promise all, and So catch executes the rejection error and becomes the outcome of the entire promise all. In case of an error, all other promises are ignored. Yeah. So multiple fetches. Um, the others, so in this case, if there are multiple fetch calls, like in the example above, and one of them fails, the others will still continue to execute. So that's important to think about too, is if you have an inkling that if you're pretty sure that one of your fetches is going to fail, then maybe don't use promise all because it'll still execute all the other ones. It's just going to trash the results. Oh yeah. A piece of shoot says yeah, all is equivalent to ampersand, ampersand, or the and symbols, and any is equal to pipe, pipe, which is or. Okay, so normally promise all accepts an iterable or like an array of promises, but if any of those objects is not a promise, it's passed to the resulting array as is. So you can also do like you could have a promise. And then also include some non-promise items. So here they've just included some integers, so you don't have to pass in a full array of promises. You could have a couple promises, some other items, and then those will all get shoved into the resulting array. Flo calls it stick stick. Well, you are a tree, so that makes sense. Okay. And a newer thing though is promise all settled. Now, what does that mean? So, promise all rejects if any promise rejects. Um, that's good for all or nothing cases when we need all results successful to succeed. However, promise all settled just waits for all the promises to settle, regardless of the result. So, in this case, that this might be also be another good option too if you have multiple fetches. Um, Here we can see that what they're going to pass in are two valid URLs, which will succeed, and then one, which is a URL that doesn't exist, right? And so if we use promise all, it would fail and it would reject everything. But if we use promise all settled, um, essentially let's see what it returns. We'll just run it. We'll see what it returns. What do we get? Come on, run. Oop, took a hot minute. All right, so it resolved the first URL. It resolved the second URL. And then for the third one, it just returns an error, which is actually pretty convenient, right? So I think this would actually be really, really useful, this promise all settled, because not only do you get your valid results back, you can get a nice detailed error about which one went wrong, and adjust it as needed. So I hadn't heard of promise all settled before, but I think that might be really useful for multiple fetches at the same time. And here they tell you how to do it for older browsers. We're going to ignore that for now. We're just assuming that everybody's up to date, right? Not good for real production code necessarily, but let's keep things simple for now. Okay, so promise race is another option that you could use. I'm not quite sure like what would be a practical use case for this. I'm sure there is some, but essentially what you're doing is you're creating like a race condition of you're saying like I'm going to run multiple things at once, and I just want to get back the thing that finishes first. So it's similar to promise all, but it waits only for the first settled promise and gets the result or an error. Rascal says also useful. So promise all settled is also useful if you don't really care about the failing one, but you don't want that one failure to stop all the others. Flo said, "Our promise is used outside of APIs." Yeah, absolutely. We talk about it mostly in the concept concept of APIs, just because that's kind of what we've been using them for so far. But yeah, they can be useful in any sort of code that you want to execute in a sort of predetermined sequence, right? Any code that you want to execute in such a way where subsequent code relies on the result of previous code. A racing website that races multiple APIs against each other. Yeah. Okay, so the next one that I think is more important maybe is promise any. So essentially, so it's similar to promise.race, but it waits only for the first fulfilled promise and gets its result. So promise.race would just return the result of whatever finished first, whether it was um, you know fulfilled or rejected, right? But promise.any says, all right, I'm going to wait for one that actually works, and I'm going to throw that one back. So if you have an API, like if you maybe have a few different calls to different APIs, and you only really need one of them to succeed, you can use this and it'll just bring back, all right, the first successful one, that's what I'm going to return. So in this case, what they're doing, they're demonstrating this by they're passing three different promises. One of them is going to be the first one that finishes, but it's going to reject. It's going to throw an error. And so promise.any will trash that. And it'll say, all right, the second one, let's look at the second one. That's the second one to finish. It's going to resolve with a one. And so that's the one it's going to return. Oh, Rascal, that's a good point. So Rascal says something they also enjoy promisifying is the loading of images. Yeah. So if you use JavaScript to set the source of an image tag, there's an unknown amount of time from the setting of that source to the rendering of that image, because images could take a long time to load, right? You could have, slow network or whatever. So if you wrap the image load event in a promise, you can wait for the image to actually load on the screen and then do something else. Yeah, so you don't want things happening necessarily before that image is fully loaded. So you can have a promise to wait for that image to load and then keep going. Yeah, that's a good point. I like that. Okay, we're going to skip the resolve and reject methods for now. We're going to go straight to we're going to go to because we're going to kind of cover that in like async await. Because yeah, they're rarely needed in modern code, so we're going to skip them. That's not to say you won't ever see them, um, but I think we kind of know, like, when a promise is resolved, that means that it's considered um, successful. When a promise is settled, that means it's done, whether it was successful or not. But when a promise is resolved, it was considered successful. When it's rejected, it's expected to return an error, right? So that's just the general concept there. Okay, so we're going to take a quick look at permissification, and I think we're going to skip microtasks. You can read about that if you want. It's more of talking about the logic behind how code is executed and why we kind of want to use the kind of the order of operations for when things actually happen in on the back end of things. But yeah, we'll talk about permissification briefly, and then we'll head on to the real star of the show, which is async await. Oh, and Rascal, yeah, that's a good example. I want to touch on that. So, um, Rascal's example of using promises. So, my example was I had a button that fetched random animal images, but I didn't want the user to accidentally click the button multiple times until the images were done. So, I disabled the form when it was clicked, and then re-enabled the form once all the images were done. Yeah, so you don't want people just spamming the button, right? You want to wait until the initial button click has fully resolved. Yeah. Okay. So we've been talking about permissification a little bit, um, but just to kind of reiterate what that actually is. So it's the conversion of a function that accepts a callback into a function that returns a promise. Um, so such transformations are often required in real life, as many functions and libraries are callback based. So just if you're working with production code, this might be something that you see. But promises are more convenient, as we've seen before. Promises are more convenient than callbacks, so it makes sense to turn them into promises. So they have the script here that has multiple callbacks, and instead we're going to turn that into using promises instead. So we have our script here. It does some stuff. It has something that happens on load and then something that happens on error. It does two different things there. Instead, what we're going to do is we're going to turn that into promises. So we create a new promise with resolve and reject, run load script, or sorry, create this load script function, and essentially just say, hey, if there's an error, reject it, and if else, resolve. So the new function is a wrapper around the original load script function, and we kind of did that earlier with the circle exercise. We just basically wrapped it in a promise, right? And we set the resolve to essentially run the thing that we wanted to run when the promise was completed. Okay, so I just wanted to touch on that to say that you may occasionally have to take callbacks and turn them into promises, for other libraries or older code. All right, so let's go. Let's move things along here a little bit, and let's head on to async await, which is a more friendly way, I suppose, of writing promises. Okay, so we have this. Oh, hey, Babel. Welcome, welcome. Well, we started about and 2.5 hours ago. Um, but you can always catch the VOD. The VOD is there for you. You're welcome to catch the recording. You can stick around. We're just getting ready to talk about async await, which I think would be useful to stick around for. It does help if you know what a promise is, though, Babel. So essentially, a promise is just something that allows us to wait on code to finish before we execute additional code. So here we're just going to talk about a more friendly way to write promises. So we have a special syntax to work with promises in a more comfortable fashion, which is called async await. And yeah, this is push work. So, it I don't know if we're going to be turning it in or not. There's really not much to turn in here. There's not hardly any tasks. We're just kind of talking through promises, getting familiar with the terminology, getting familiar with what they are. I think async await is the thing that I've seen the most. I mean, I've seen promises, but I keep seeing async await in lots of places, especially related to APIs and things. So I think it's important that we get exposed to this as well. So we have a special syntax to work with promises in a more comfortable fashion, and it's called async await. So we can take a function, a regular function written normally, and just put the keyword of async in front of it. So what this means is that the function, once it has this keyword in front of it, will return a promise. So in this case, what this function gets, as soon as we put async in front of it, it returns a resolved promise. And so then we can literally take this function and start chaining thens after it, which I think is pretty cool, right? Because normally, if you can't do that with just a normal function. You can do it, but once you put this keyword in front of it, you can start using then and catch and other things, and chain them to this function. So instead of having to say new promise, blah, 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 we can just use this async keyword instead. And it's literally the same thing as saying return, promise, resolve. So async ensures that the function returns a promise and wraps non-promises in it. And then we have a second keyword that pairs with it that's called await. So the syntax of that is that it works inside of our asynchronous function and it awaits something else to happen. So the keyword await makes our JavaScript wait until that promise settles. So promise is done, wait until it's settled, and then return the result. So let's see what this is doing. So we have an asynchronous function here, and we're declaring a promise inside of our asynchronous function. So let promise is new promise and resolve that after a second. And then we have this additional variable here that's awaiting the results of this promise. So only after the promise is done are we going to alert the result. Okay, let's see what that does. Yeah, so you can see it waited a second and then returned. So the cool thing about this is that the function literally stops. It pauses. Like the code is paused at that line, and it returns when the promise settles, with result becoming the result. So again, yeah, that's why I'm emphasizing, because the text emphasizes it as well. Let's emphasize await literally stops the execution. The code pauses until the promise settles, and then it returns it with the promise, then it resumes it with the promise result. This doesn't cost any CPU resources, so you're not locking up your computer. It's not like an infinite loop where you're locking your computer, potentially, or using up all your memory or whatever. Because the JavaScript engine can do other jobs in the meantime. It's still working. It's performing as expected. It's handing out its tasks as it need to. But for this particular script, it's literally pausing the function. It's just a more elegant syntax of getting the promise result than promise.then. Okay, and but you have to declare the function as asynchronous in order to use await. You can't just use it in a regular function. And actually, I want to show you the. Wonder if I do this. Yeah. Okay. So I don't know if you can see this error, but this syntax error, await is only valid in async functions at the top level bodies of modules. Yeah. So I've gotten this error before trying to use await without knowing what it was, because it's like, oh yeah, I want to pause my function and wait for something to be done, but I didn't know what about the async keyword, so I kept getting this error. So I'm very familiar with this particular error. Okay, so in this case, if you remember previously, we had the show avatar function that we ran that basically pops up an avatar in the top left corner of the screen for 3 seconds and then takes it away. So let's see how we can reconfigure that instead of using multiple thens, chaining thens. Let's see how we can do it with async and await. Okay, so here we made the function asynchronous using the async keyword, right? And now we have everything. Look how clean everything looks. So we have a response. We are awaiting a fetch. So what this is doing is it's saying, all right, pause the code until the fetch is complete. Once the fetch is complete, go to the next line. All right. The next thing we're doing is we're awaiting our JSON response. The next thing we're doing is we're awaiting the second fetch, which contains the username. So this username right here. And then after that, we're awaiting the response again from our second call. So like, we're doing multiple calls here that rely on each other. We're doing multiple fetches that rely on each other. And it looks so clean, doesn't it? Fetch 1, get the response. Fetch 2, use some of the data that you got back from the first response and do another fetch and get the response. And then after that, do your manipulation on that data that you got back from the second fetch. So I think this is really cool because it makes it look so much tidier than having, fetches and thens. It's very clean. I like it. So, and then after that, we're doing pretty much the same thing that we did before. And then finally we have another await that creates a promise that will resolve after 3 seconds. And then we execute the last couple things. So let's run this and we'll confirm that it works just the same way as the other one did. So let's run it. Hey, it works. Oh, you can't see it there. Okay, let me do it again. I gotta move my mouse. There we go. Okay. All right, Rascal's dropping some knowledge here. Oh yeah, and Rascal says you can chain on awaited values as well. You can surround the expression in parentheses to chain multiple things. And yeah, and that's another good point, Rascal. So think about scope, right? So think of have you ever had a problem? You've done a fetch and you want to grab something out of that fetch, but it's inside of the fetch brackets, and so it's out of scope, like you can't access it. um, I have that problem a lot. I'm thinking about how to structure my fetches, um, because I can't access things inside the fetch if I want to do things outside of the fetch brackets. And it gets like, I don't know, it gets really messy thinking about how to balance your scope and how to pass things from fetch to then to next fetch. Um, and so I feel like this is also really great because it removes that problem of scope. Um, and that's exactly what Rascal says here. You don't have all those mini scopes encapsulating your previous chain results, which can be a disadvantage if your last thing needs data from the first thing. Yeah, I've encountered that. Oh, yeah, good night, Flo. Great. Thanks for coming. Great to see you. Yes, Florence. Yeah, I think this is going to be super helpful for getting different attributes from multiple fetches, different elements from multiple fetches. Yeah. Um, okay. No problem, Mikechi. Yeah. Can this be used on waiting on window events like user inputs? Yeah, I mean, I think so. Because if you're waiting on like I don't know, like a certain response to something that you've popped up in the window, for example. I mean, yeah, you could always have a promise that um, you know isn't fulfilled until you get a certain result, right? Back from the user, like a valid input of some kind, and then it only continues once that's resolved. Yeah, you could have an await that's awaiting a valid input from the user. Yeah, yeah, I think promises would be a good application of that. Yeah, you can, and like Rascal says, you can promisify an event listener result. Yeah, you can turn it into a promise, and so that way you don't have to like um, that way you don't have to like hack it. You can just wrap it in a promise, and have it be suspended and await a certain result back, and then only continue after that's been fulfilled. Yeah, so I think it's pretty cool. I especially that scope thing is going to be a game changer for me. I have scope problems. Yeah. um and two, we previously said that you need to wrap your you need to like you need to wrap things in an asynchronous function, right? But older browsers did seem to also require actually making making an asynchronous function, like with this syntax where we got extra parentheses around the outside and you're passing async in as like you're like turning it into an arrow function. But I haven't encountered that. It seems to be like, again, in modern browsers you should be fine. So yeah, Rascal, and that's, yeah, too. I think we touched on that a little bit. Is that when we did that circle exercise earlier with the animated circle where it had a callback, we were permissifying that. We were turning it from a callback into a promise. Yeah. We're gonna skip that one there. Okay, this is cool. So we've talked about classes, right? So we've talked about making classes, and you can also have asynchronous methods inside of classes as well. Um, so I can't think of it like immediate use cases for that, but just know that if you're trying to be object oriented and you're building classes, you can make methods inside of classes be asynchronous as well. Um, so like I said, I haven't used that yet, but it's cool to know that that's an option. So if you want to be strictly object oriented, building classes and constructors, you can use asynchronous methods as well. Um, so error handling. Let's see. So if a promise resolves normally, then await promise returns the result. So it's just like if return the result manually. In the case of rejection, it throws an error, just as if there was this throw statement at the line. So okay, if it works, it returns a result. If it doesn't work, it returns an error. And so if there is a delay in that error being thrown, you don't want to miss the error. Like we saw earlier in one of the earlier tasks, right? There was a timeout. There was a timeout set, and so the catch actually didn't catch the error, right? Because because the promise had concluded fully before the error was actually thrown. So you can also wrap your function inside of a try catch statement, which will try first, await the response, and then catch whatever gets thrown back. In the case of an error, the control jumps to the catch block, and we can wrap multiple lines in our function inside of a try, which will make sure that the error is caught on any of those lines and passed into the catch. And also too, we can also append catch after the fact. So just like we did before, like we're more used to seeing. So instead of using catch in sort of more of that if else format, you can append catch like we're used to seeing with more old fashioned looking promises, right? So you can still do that as well. So you can declare the function first, and then you can append the catch later. You can also append then as well. So it's kind of flexible in that way. So you can use this newer syntax of async await and then append then and catch later on if you would like to. Oh, thanks for the stretch. Yep. Oh, I got a wrist pop that time. Double wrist pop. And so, yeah, it's true that if we're using async and await, so async and await are kind of replace then, right? Because await essentially performs the function of then just in a more compact format. So instead of having to do then with the brackets and do all the things inside of our then, we just say await and write out our statement. However, you can still use them, just like I said. So if you're outside of the function, you can't use await. Await only works inside of our asynchronous function. So if you want to add a then statement to the outside of the function, so if you want to do something after your asynchronous function, you can just append it on. And we'll see that in a second. Okay, so I think that's we'll see that. I think we'll see that in one of the tasks. Okay, so let's test this. Let's test out this new format. So they want us to rewrite this example code from the chapter promises chaining using async await instead of then catch. I'm gonna hydrate here. Okay. All right. So they want us to kind of restructure this so that it looks more similar to this new, so it uses this new terminology that we've just learned, which is async await, right? So what do you think the first thing is that I should do? Before I try to actually get into the function, like before I get it too deep into thinking about how to restructure this, what is the first thing I need to do to make this function compatible with async await? Rascal's not allowed to answer. Hey, you guys are quick on the jump. Nice. Yeah, we just need to put async in front of it. So I'm going to grab this and put it some. Oh, can I edit this? I can. Good. Can't always. Oh, I don't want to do it in this. Yeah. Well, let's see if it'll actually even run it. Error 404. Okay. Well, I mean that's it. That is what we expected. So, all right, cool. We'll edit it in here. Dip in candy. All right. So essentially, in front of this, we just need to put the async keyword, right? This is saying, all right, this is going to be an asynchronous function. We're going to have some pauses in here. We're going to have some stops, stopping and going, right? Oh, got to get rid of this. Stop executing. Okay. All right. So that's the first thing we need to do. And we see that we have a fetch and a then, right? So we don't want that then keyword inside of our function anymore. We don't need it. We can use await instead. So let's step one, eat chocolate. Step two, async. Yeah, exactly. Hey, I don't disagree. All right. Stop executing. I don't like this this editor. Okay, I'm done. It's like CodePen, but worse. All right, I'm just gonna grab it and we're gonna drop it into the console. Not doing that. Yeah, I wanted to stop executing until I actually tell it to. So let's put it in here. All right. Okay, so instead of returning and then a then, zoom in a little bit there. Instead of returning and then a then, really, I just want to say I want to put my response into a fetch. So we're just going to say let response. So the first thing I want to do is I want to await a fetch, and we're going to grab the URL. We're going to fetch whatever URL we put in, right? So I don't need this anymore. And I also don't need the then, right? Because we're already awaiting the fetch. So it's going to wait until that fetch is done. And then only then it's going to go on to the next thing. So we don't need the then anymore. So now it's going to say, all right, if response.status equals 200, return response.json. Cool. Else, throw an error. And that's really all we have to do. So we got rid of essentially that whole then. And I think actually I probably have an extra parenthesis now. Throw error status. Yeah, I don't need this. I don't need these extra parentheses, I don't think. All right, so when I run this, I'm expecting an error 404, but we'll see if it works. Oh, and I didn't all that talk, and I didn't replace the async. Hang on. Missing async. Yeah. I didn't retype it. Yeah. All right. There we go. But you saw the error that it gave you. It basically said, "Hey, you can't do an async function without calling it async first." Yeah. All right, and that's good. So you can see that even though we never declared a promise, we never said new promise. But the very fact that we made this function async created a promise, right? That's what we said it would do. It said it was going to wrap things in a promise just by making this function asynchronous. Um, and that's exactly what it did. And so this URL was not valid, no such user.json. And so the URL that we passed in was not valid. So it went through, it waited the fetch result. The response status was not 200. So it went to the else and it threw an error. And so then that error then went down into the catch bucket. And we get our error 404. So it worked just like a promise, but is much easier to read. Yeah. So I think I might try to go back and like take some of my older projects and rewrite them using async await. I think it's pretty cool. All right, so that was the first one. And now we get to rewrite another one. This one's a little bit longer, but it's really not that bad. It looks kind of intense, but below you can find the rethrow example. Rewrite it using async await instead of then catch, and get rid of the recursion in favor of a loop in demo GitHub user with async await. That becomes easy to do. Okay, so let's take a look at this. So we have a class with a constructor, and it's building some stuff. We have a URL, and we're going to fetch that URL. We're going to get a response. This looks familiar. We just did it, right? Async wins. So we get a response back from our fetch. And then if it doesn't work, we want to throw an error. So we just did that. So we should be able to clean that up pretty easily. we want to prompt. So this is kind of similar. Somebody was mentioning earlier about waiting for user input, right? Waiting for valid user input. And so that's essentially what we're doing here. We want to keep prompting the user until they give us a valid input. So in this case, we're going to prompt them to enter a name, and we're going to run it through our load JSON function to get some stuff back from the GitHub API. And so we want to see, all right, did we get back valid JSON, or did we get back an error, which would indicate a non-valid username, right? So we're going to run this JSON function. Then it's going to grab what it gets back. It's going to alert the name. But if it gets an error, if we threw an error up here, if there's an HTTP error, we're going to drop it down into our catch bucket. And if it was an HTTP error, we're going to say no such user. And then we are going to, right now it's recursive. It's gonna essentially prompt the user again for another entry, right? We're gonna go back to the start, have them try again, have them enter something else. However, and then if it's another error that it can't parse, we're just going to throw the error. But they want us to rewrite this using async await and removing the recursion. So the things they asked us to do were rewrite it using async await instead of then catch. Get rid of the recursion in favor of a loop in demo GitHub user with async await that becomes easy to do. Okay. All right, so let's get this into a place where we can edit it. Okay, so we don't really need to make any edits to the constructor, right? So we can kind of ignore the constructor. And we've done this before as far as cleaning up a fetch, right? So in this case, we can just say response is going to be, we're going to await a response from our fetch. So equals await fetch URL. So that's going to await until the fetch is done. And then we can go straight into our if statement because we know that the fetch is going to be done before that if statement runs. So fetch is going to run, if statement's going to run. Get rid of these extra parentheses here. Okay, so do that, get back a response, throw an error if we don't get a valid response. Oh, yep, good catch. We got to put async in front of our, I get the feeling I'm going to forget that a lot. Just, yeah, I get the feeling that's going to happen a lot. Good to practice now though. All right, so we've made our fetch asynchronous. And now we're going to go down to the demo GitHub user function. Okay, so I don't know if you guys remember, but way back a long time ago when we were first learning about loops, do y'all remember like the, I think it was JS Way. There was some JS Way homework where we had to keep prompting the user until they entered a valid number. It was like they have to enter like a number, like I don't remember if it was a specific number or whatever, but we had to keep prompting them until they entered a valid number. Do y'all remember how we did that? How much you do that? How much you keep prompting someone until they return a valid response, until they give you a valid input. Yeah, Rascal, it was something like a number less than 100. Yeah, exactly. Yeah, so we can do this using essentially using a while loop, right? So we don't need recursion here. We don't need recursion to force the user to keep being prompted. We can do it in a more friendly way by using a while loop, which essentially keeps asking for a prompt, right, until they give us a valid input. So we can get rid of the recursion. And instead, we can, we can add a while loop. So all right, so essentially here we're going to say, let's see, while, yeah, and there's various ways we can do this. I mean, you could have like a flag that flips. You can have a flag that flips to, to true as soon as a valid input is entered. So you could have like while flag equals false, or while, well, essentially you could just have like while flag, and then you could declare a flag and have it flip. Um, as soon as a valid input is entered, so it would be true, and the while loop would end. In this case, the way the solution does it, I thought was kind of interesting, so I'm gonna do it that way. I mean, the way that I would have thought it would be to have some kind of a flag that does the flip, but we're gonna do it this way. So it's basically just while true. So that this seems kind of dangerous to me. It seems as though there's the potential here, if you write this wrong, that it could keep running forever. But I think it's kind of interesting anyway. Um, so we're going to start a while loop here, and just like before, we're going to declare our name, and it's going to throw a prompt up to the user. And then what we can do from there is we can essentially start a try catch. And so what that's going to do is it's going to try to execute what we give it, and then if that fails, it's going to toss it to the catch. So instead of the then, like the then catch like we had before, we're gonna substitute that with a try catch. All right, so which we haven't really done try catch yet, but it's kind of, I mean, it's similar to like having multiple thens and then having a catch. It's just you can wrap multiple lines inside of a single try. So we can do try, have that, and then inside of that try, we're essentially going to replace that. Let's see, I'm going to just get rid of this. Inside of a try, we're going to have our user. Oh, and I didn't declare my user either. I'm sorry. I have to declare my user outside of my while scope here. So we'll have a user so that as soon as they give us a valid user, that while loop will end and we can do other stuff with it. So the user then is going to be, it's going to await the result of our load JSON function. So essentially, remember, our load JSON function is just doing the fetch and giving us back the result, right? So we want to await that result. Load JSON. And we're going to pass in our URL. I need to copy the URL again. Okay, so pass that in. And then assuming that user is valid. So assuming that user is valid, we then want to essentially end the loop, right? We don't want to prompt the user again if they've given us a valid name, right? So we don't want to prompt the user again. So a quick way that you can get out of a loop, right, is simply to use a break. And so that's why that this while loop essentially has the potential to keep running forever. However, in this solution, they have decided to use a break to break us out of the loop kind of manually that way, rather than using a flag. Personally, again, I would have used a flag here, but this is what they decided to do. So I thought it was interesting, so decided to try it. All right, so our try statement is essentially over. And if the user that comes back from our fetch is not valid, it will immediately throw an error. And so then we want to dump that into our catch. So we pass the error into our catch. Catch error. I don't know if you guys can see still. It's kind of low down on the screen. I can't hardly see over my laptop. Pass that into our catch. And then we have our if statement, which I accidentally deleted. If our error is an HTTP error, alert some stuff. I'm gonna move the screen down a little bit. There we go. If it's an HTTP error, alert some stuff. And then I think, was there an else here? Else, throw an error. Oh yeah. Okay, that's good to know. If I can change it to the left. Yeah. Thank you, piece of shoot. Yeah, that's helpful. I'll figure out how to do that. Because yeah, my webcam's on the right, so I don't want you guys to not be able to see me. All right. Another two, just in case you didn't know, you probably did know this by now, but if you're writing code directly in the if you're writing code directly in the console, you can, of course, you can tab to indent your code, right? But if you want to indent in the other direction, you can just do Shift Tab. So that way you don't get messed up in brackets everywhere. Okay, so what have we done here, right? We've declared our user. We've checked to see, so we've grabbed, we've prompted the customer or whoever to give us a name. And we've then passed that name into a fetch and assign that to a user variable as soon as the fetch is complete. So we're awaiting that. We're awaiting the completion of our load JSON, which is essentially a fetch, and we're waiting for that to be done. We assign it to user, and if that user is valid, as long as that doesn't return an error, then we break out of the while loop and we don't prompt the user again. However, if it was invalid, if we got an error here, that goes into our catch and we check to see what type of error it is. And we also give them a handy dandy alert to say, hey, no such user, please re-enter. And then because it's a while loop, it'll run again, right? It'll keep running until they give us something valid. Because we have this break statement in here. As soon as they give us a valid user, it breaks us out of the while loop. Else, it will keep going forever and ever. Okay, and so after that, assuming they eventually do give us a valid user, we will have it be assigned to this user variable, which was outside of the while loop, right? So it's outside of the while loop. My auto moderator is funny sometimes. It catches the weirdest stuff. You all are too wholesome for my auto mod in my chat. It gets bored and it catches random things that don't even make sense. You're too wholesome. Don't start spamming me with nasty stuff though. I like my wholesome chat. Okay. Kuchifin, oh my gosh. Thank you so much for the Prime sub. Spend Jeff Bezos' money. Do it. Yeah. Spend all his money. Anytime you buy from Amazon, use your Prime to subscribe to somebody on Twitch. Balance it out. It's the best way. Thank you so much. I really appreciate it. I really do. It means a lot. Okay, so we have our user info assigned to our user variable. Pineapple on pizza. Bozo Bezos. Yeah, I like that sentiment, Kuchifin. Awesome. All right, so we have it in our user variable. Now, essentially, the last thing we have to do is just alert the information to the user. So let me see. Hopefully, I've got my parentheses right here. Then we're done with the while loop, so we're just going to alert it outside of the loop. Alert full name is just going to be, so we remember we got back a bunch of JSON data related to the user, so we can just dig into that and find their name and print it to the console. All right. And then the last thing is actually, we do actually want to return that data out of the function as well. All right. Okay, so theoretically, that should work. Oh man, I need a new channel points reward for when I forget async. I think I think I need like a new sound. I need a sound alert or something that's like gonna, you know, that y'all can trigger when I inevitably forget to put async in front of a function. Yeah, and actually, unfortunately, we can't run this because it extends a, like it extends a class that we don't have here. Um, but I think it is cool to figure out how to rewrite something to use, you know, async await. So we can't run it, but it should work theoretically. But yeah, so basically what we did here is we just practiced. Okay, in general, I think this little chunk like here um, is probably like useful to know, right? How do I rewrite a fetch to use async await? Um, and how can I then use that data later um, using further awaits in order to get more, extract more information about the data that I've gotten back. So I think it's cool. Like um, Rascal was saying earlier, you get rid of all those scope issues when you have you know, before in when you were using fetch, and then you get rid of those scope issues with the extra brackets, and you can be a lot more flexible about how you use this stuff. So okay. We have one more question, then we'll wrap it up for tonight. All right, this one's fairly small. So we have a regular function called f. How do you call the async function wait and use its result inside of f? Okay. So what do we have here? We have an async function, which is awaiting a promise with a timeout, and it should return 10. Now, where we want to write here is inside of this function of f. And what should we write here? We need to call async wait and wait to get 10. Remember, we can't use await because now why can't we use await? I can't keep trying to edit this and I can't. All right, I'll do it in here. Come on, reload. Oh, I didn't ever run this. So. All right. Okay. So why can't I use await inside of this? Hi, Dan Bell. How you doing? Oh, yep. Dan Bull and Strain have got it. We can't use await inside of here because this particular function is not asynchronous. We could make it, you know, we could potentially make it asynchronous, but let's leave it as is and let's figure out how we could potentially, essentially, how could we potentially wait for the resolution of the wait function and then do something else? How could we potentially do that? So we're going to want to do something with wait, right? We want to call wait and something else should happen afterwards. So how would I do that? Considering that by using this async keyword, we're essentially creating a promise, right? We're essentially making the result of this function into a promise. How could I say, all right, call wait, and then something else should happen after wait is completed, after the promise is fulfilled? Yeah, I like what I'm seeing. I like what I am seeing. Yes. Y'all got it, right? We've created a promise, so we can just go old school and use then. It's not asynchronous, but it doesn't like we then works on promises, right? That's how we change stuff with promises. Out, I'm forgetting all the this asynchronous notation and stuff. Then works just fine. Yeah, dot then exactly. Yep. So essentially, then we just want to. What did it say? What did it even tell us to do? How can you call the async function wait and use the result inside of f? Okay, so we want to essentially pull the result out of f, out of sorry, we want to pull the result out of wait and use it inside of our f function. So um, in order to do that, we can essentially just have a then and then grab the result and then console log or alert or whatever we want to do. Right? Because essentially with our async, we've turned wait into a promise, and so we can use all the promise stuff that we already learned, just like we did before. All right, so let's go ahead and call it and see what we get. Oh, there we go. Okay, so we can see that what we get is we have our async function. It waits 1 second, returns 10, and then our f function gets the result. It waits until wait is done, and it gets the result, and then it alerts the result. So let's modify this just a little bit. Last thing we're going to do, let's modify this just a titch, and we're going to increase this timeout so it's a little clearer. Put it up to 10,000. No, 5. Okay. So we should only get an alert after 5 seconds. Let's see if that's the case. All right, so then I'll go ahead and call this. There we go. Yeah, so that worked just fine, right? No difference. Yeah, so I'm sure we're gonna, I'm sure we're gonna talk about async await a lot more. Personally, I'm excited to rewrite a lot of my API calls and make them a lot cleaner and easier to use because I was really banging my head against like I keep saying, I was really banging my head against like scope issues with fetches and stuff like that, having things be inside the brackets or outside the brackets or what order I needed things to be in. And I really think async await is going to help that quite a bit. So obviously this was the push work, and I know I dumped a lot on you here, but I think now if you go back and you like read the regular homework, it should be hopefully easier to like you should see some of these concepts being repeated. And I haven't done the YouTube video yet, but I'm sure that's probably very helpful as well. So definitely go through the examples in the other, in the regular homework that we were assigned. That one's a lot shorter. Go through that, type out all the examples, see if they make sense to you, and then also do the YouTube video as well. So yeah, that's about it. Any questions before we wrap up? I try to make a short stream and I still go for 3 hours and 20 minutes. Seems like I can't not go for less than 3 hours. I try, but it doesn't work. Yeah, and this is going to be as an intro. I don't expect you all to come out of here like totally comfortable with promises. It's just more of like here's an introduction to what promises can do, and how they could potentially help you. Oh, DMAC, good. Thank you so much. Yeah, go over it yourself. Take your time, try it out. Um, yeah, no problem at all. Good. I'm glad it was helpful. It's helpful to me to talk through it. So at the very least, I'm being selfish by just saying, hey, I need to learn more about this. I'm going to tell it to all you guys. We'll do it. We'll do, depending on if we have a stream on Sunday, we'll try to do something more fun. I know this is a little bit of a slog, but I hope that maybe we can do, something fun on Sunday stream, like a project or something. We'll see. I don't know. Depends on how long Leon's super review goes, right? I might get preempted. All right, let's set up an array. Let's set up a raid, not an array. We're going to set up a raid, and think of someone to raid. Let's see. Get it pulled up here in my other window. All right. Anybody have any suggestions or check out see who's online? We always try to rate somebody who is in the if we can, we try to rate someone who's kind of in the 100 devs community or um, is a cool person. Polarin, okay. I'm gonna just take a look here. Polarin, okay. Let's. Sorry for the echo. 2 seconds. Raid. Polarin. What do they do? Oh, software and game dev. All right. Awesome. Have we rated them before? Hey, they only have 9 viewers. So let's surprise them a little bit. Let's do a wholesome raid on them. Yeah, I don't think I haven't rated them before. So yeah, let's give them a raid. They only got 9 viewers. Let's hit them up. Yeah, I'm sorry. I must have forgotten that we rated them before. I guess I forgot to follow them because they weren't on my list. But all right, let's hit them up. I'm gonna start the raid. Oh, I remember them now. I had to see their face to remember them. I remember them now. I'm really bad with names. All right, raid is going to kick off here shortly. Thank you all for coming tonight. Like I say, again, I know this was a little bit of a slog, but I think still think it was worthwhile. And we try to alternate between fun and less fun things on stream. So, all right, well, enjoy the raid, and I will see you again very soon. Oh, we still got a few more people getting on the raid bus. Yeah, the alternative is you got to slog it on your own. So we might as well share the pain together. All right, here we go. Rating now. See you soon.